Hello, hi, namaskar everyone. Once again, welcome back, welcome back, welcome back. I hope now I'm clearly audible and visible and there is no issue of buffering anymore. Just remember one thing in life, if something is making you wait for a little longer, then have patience because great things take time. Remember it, always remember it. So yes, again, we are starting from the basic, the beginning. In this session, we'll be revising all the formulae of your entire mathematics for your IIT JEE Advanced preparation. Yes, this session will be conducted for mathematics right now, but yes, if the demand arises, we could be conducting it for physics and chemistry as well if the need arises. Yes. So I'm really sincerely apologizing for that. You had to wait for possibly for another straight half an hour. I'm really sorry for that. But yes, always remember, as we have already discussed, great things take time. Just give me a quick update. Am I clearly visible? Am I clearly audible? I hope there is no buffering anymore and you can hear me and see me properly. Great, 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 great. With that, let us get started. Yes, here we are with this session, with this amazing, phenomenal session, and something very clear and straightforward, pylons. You can download it from Play Store or Chrome Store. What is the advantage of it? You can participate in the polls conducted by us, or if you're watching any random video on YouTube, you can get a quiz created on it. You can get PDFs of mind maps and a lot of short notes on it, and you can of course receive or have PYQs based on that topic of any video which you are watching on YouTube. An amazing platform which helps you a lot in preparing for your exams. This session is divided into 5 chunks. Yes, Navneet, I think I have answered your query. If the need arises, we could possibly conducting this formula revision session for physics and chemistry as well if the demand arises. So if you need that, if you want that, you can definitely put it in the comment box. We'll be having a discussion on that as well. Don't worry about that. So let us get started with this discussion. I hope I'm clearly audible and visible to all the participants. With this, give me a moment, students. With this, give me a moment. We are starting. Okay, so here we are. We'll be beginning our discussion with calculus. After calculus, possibly we'll be switching to vectors in 3D. Then we'll be moving towards trigonometry, coordinate geometry, and algebra. This is how the flow will happen. Algebra I may shift earlier, and this is how things will happen. I am your old teacher, sir, your old teacher. Okay, great, 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 great. With that, let us get started. Thank you, thank you, thank you, thank you. Perfect, perfect. So with this, I'll be showing you the direct formulae. I'll not be discussing a lot of them since you are preparing for JEE Advanced. This is what you all are already aware of. One thing I'd like to highlight here is this particular one. I hope you know this very clearly that when you talk about this particular formula, it is simply log x base e. There you differentiate it as 1 by x. But if it is log x base a, then I hope you remember the derivative is 1 by x log a base e. Simple, straightforward. Sir, what if we want the PDF notes of this session? You can have this entire PDF in on your WhatsApp by simply following our WhatsApp channel. Sir, how do we follow our WhatsApp channel? You can follow our WhatsApp channel by clicking on the link given in the description. With this, these are some straightforward formulae. I hope you remember them. I need not give you clarity on that. Something really simple you need to remember is for sine inverse and cos inverse. The only difference is negative sign. Same is there with tan inverse and cot inverse. If you differentiate it, the only difference is this negative sign. But when you differentiate it, you remember these conditions as well. In this session, it is merely our entire revision of all the formulae. So here we'll not be solving questions, we'll be making you revise all the formulae. Akhil is asking how to find WhatsApp channel. To find our WhatsApp channel, the link is given in the description. If you click in the description, the link to our WhatsApp channel is given. And after the session, entire PDF of all the formulae of this entire mathematics of your IIT JEE preparation will get uploaded. Right, with this I'm moving ahead with this discussion. Something really simple and understand. For product formula, we know that fx into gx, if that needs to be differentiated, we do it simply by differentiating first function, keeping second as it is, plus differentiating second, keeping first as it is. For 3 or more functions, what do we do? For 3 or more functions, the idea is really simple. You differentiate first function, keep the other 2 intact, and then you differentiate the second function, keep the other 2 intact, you differentiate third function and keep the other 2 intact. This is how you differentiate it. What is the duration? Possibly within 2 hours I'll be done, and after 2 hours you'll be having your PDF on your or at your fingertips. I think quotient formula you need not discuss here. Something really important, amazing, which you should remember is that let's say you're given implicit functions. Sir, in that case, how do we differentiate? Is there a short trick? Yes, there is the short trick. Now, The short trick is, let's say there is an implicit function given to you. Let's say there is an implicit function given to you and you want to differentiate it. For example, x square plus xy plus y square, and you're asked to differentiate it. This is a function in x and y both. And there, let's say I want to differentiate it. So the short trick says, of course, pay attention to this part. The short trick says here, one of the methods is logarithm. That's a very good suggestion, Rohit. That's a very good suggestion. But here, for implicit functions, the short trick says you differentiate the function partially with respect to x, put a negative sign before it, divided by the derivative of the same function with respect to y, partial derivative. If you do that, you will again get nothing but dy by dx. Is it not simple, straightforward, and amazing? Will you remember that short technique? For example, here, if I want the value of dy by dx, it's really simple. First of all, put a negative sign. Now differentiate x square plus xy plus y square partially with respect to x. So it will give you 2x here. Xy becomes y when differentiated, y square becomes 0 because y will be a constant here. In the denominator, differentiated with respect to y, so x square becomes 0, xy becomes x, and y square becomes 2y. That will be your dy by dx. Isn't it interesting and amazing? Yes. Now, you need not convert it into a perfect square. That's what you've got to remember. Some trigonometric identities which I want you all to keep at your fingertips, because in JEE Advanced, you'll be requiring them a lot. First one, of course, you know. Second one, these versions, I hope you remember it. This is something which is very prominently, widely, and at a lot of places used by IDJ. Now, of course, the versions of sin 2x and cos 2x formulae in 10, because we need it in integration as well. And when we talk about this version, 10 2x, we already know that. And this version of sin 3x, this third version, I hope you are seeing it. Sin a, sin 60 minus a, sin 60 plus a is always 1 by 4 times sin 3a. Do you remember that? Here it should be x instead. So this should be x instead because there it is a. So I hope you got that correction. You understood that correction. Remember this formula. There are a lot many times direct questions asked on that property. Let me move towards the PC. Yes, there it is. I repeat my part. A lot many times direct formula based questions are asked based on this formula. Remember that. So great. Moving ahead from here, what do we see next? Yes, again, another version of cos 3a. We know for cos 3 theta, it is 4 cos cube theta minus 3 cos theta. But again, I'll ask you to remember this version because this is something which is missed by students. And if you remember it, you will be saving a lot of time of yours in the examination hall. If you divide cos 3a by sin 3a or sin 3a by cos 3a, of course, you'll get tan 3a. So one of, again, the most useful version is tan 60 minus a, tan a, tan 60 plus a. Please remember this version. Although you already know this, I hope there is no confusion on this. Tan a plus tan b plus tan c minus tan a into tan b into tan c upon 1 minus tan a tan b plus tan b tan c plus tan c tan a for tan a plus b plus c. That's the formula. If I replace a, b and c all by x, I'll get tan 3x, and I hope you remember that formula. Okay. If you visit our WhatsApp channel, you will start seeing the notes. I have ensured that they are uploaded. Now, if you visit our WhatsApp channel, they are uploaded here. I hope this is again something very commonly and widely used, and on this questions are asked. Sir, how is this formula derived? I hope you remember. If you multiply and divide it by 2 sin a, if you multiply it and divide it by 2 sin a, of course, a chain will become 2 sin a cos a, then 2 sin 2a cos 2a, and so on. So that's how finally you conclude this formula as this. Even if you don't remember the direct version, you can derive it in the examination hall. With this, moving ahead with this next discussion, this logarithmic differentiation, I'll always remember or ask you to do it in this manner. Avoid following this short technique. Right now, it may confuse you unnecessarily. What does it mean? It means, let's say there is a variable to the power variable. Let's say y is given as a function u of x raised to the power v of x. Then we always remember it that, sir, take logarithm on both sides and differentiate. Of course, there is a short technique, but avoid doing that. I hope you remember all of these formulae, all of these notes you can avail by just having or following our WhatsApp channel. There, after the session, we'll be uploading this entire PDF for you all. Do you remember that? For determinants, I hope you do remember that if there is a determinant which has functions of x as its all of its elements, then if I wish to differentiate this determinant, we can do it either row by row or column by column. So if I'm doing it row by row, first row, other two rows intact, second row, first and third intact, third row, first and second intact. Do you remember that? Now, a lot many times what we need to do is we need to define the functions. Let's say this is based on number of functions. This is based on number of functions. So let's say there is set A, there is set B. So from set A to set B, we are defining a function. Now what is happening over here is, pay attention to this part, students. From set A to set B, set A has m elements, set B has n elements. How do we define the total number of functions? I hope you understand. Each of them have n choices. X1 has n choices. I hope you're understanding. X2 has n choices. So technically, all of these m elements have n choices each, which means n into n into n. M times that gives you n to the power m as your total number of functions. Did you all get that? So if somebody asks you that domain has m elements, codomain has n elements, the total number of functions will be number of elements in the codomain, number of elements in the codomain raised to the power number of elements in domain. Did you all get that? Did you all understand this? Now from here, the next part. This is something where you should pay a lot of attention, because on this questions will be asked. Remember this result very widely, very clearly, that if you are given a functional definition which follows this definition, fx into f1 by x is given as fx plus f1 by x, then always unhesitatingly take f of x as 1 plus minus x to the power n. Do you remember that result? Okay, you want me to slow down? Great. Okay, I repeat, I thought you know all these already. I just need to give a glimpse of these. I'll slow it down. So here we know fx into f of 1 by x is given as f of x plus f of 1 by x. Let's say that's the functional definition we are given in a question. In that case, you can directly take it as 1 plus minus x to the power n. The function f of x can be taken as 1 plus minus x to the power n directly. And a lot of times questions are asked based on this property. Now, sir, how do we define or how do we find the value of n, or what is going to be there, either plus or minus? That data, that additional information will be given to you in the question, which means you will be given certain information through which, or with the help of which, you will be in a position to crack n, and whether it will have plus or minus, that also you will be able to crack. Did you all get that? From here, when I move ahead, what do we see next? Properties of modulus. If I could highlight the most important one, I hope this is something you all should remember. Always remember, there students commit a lot of errors. They get finally under root over x square and they tend to replace it by x, and that's again where they get the wrong answer, which means under root over x square is always modulus of x. Please don't forget that. If you are writing JEE Advanced, you must be aware of it. I am sure of that. Now, these are your triangle inequalities. I want you all to remember these two specifically. I hope no doubt or hesitation on this, that whenever mod x is less than equal to 3, then we can directly write that x lies between minus 3 to 3. And if mod x is greater than equal to 2, then we say that x will be either less than minus 2 or greater than 2. Do you remember that result? So I hope you know these two results. Yes, we'll talk about everything, all the formulae of entire mathematics of your JEE Mathematics for Advanced will be discussed in this marathon, and after the session all these notes will be uploaded on our WhatsApp channel. The link to the WhatsApp channel is given in the description. You can check it by yourself. This result again you got to remember, which is again a very crucial one. Let's say instead of deriving it time and again, you can remember it directly. Let's say I'm told that x lies between a and b. X lies between a and b, then we can directly say that x is from minus b to minus a or a to b. The same result you can keep for x square as well. Let's say somebody says that x square lies between a square and b square. Then this also concludes the same result, that x will lie between minus b to minus a or a to b. Do you all remember that result? All the participants, give me a quick update on that. Now, from here, the next conclusion is this. I hope you remember there. Let's say if you are asked to find out the range of a rational polynomial. Technically, in this rational polynomial, numerator is also a quadratic, let's say for a while, and denominator is also a quadratic. So in functions, how do we do that? Do you remember that modus operandi? Do you know that set of rules here? Now, here pay attention to this part, students. What do we do here? First of all, we put it equal to y. Then denominator is pushed here, and there by readjusting it or arranging it, you get a quadratic in x. You get a quadratic in x. Then what do you do next? After getting a quadratic in x, you define its discriminant, and we know that this y is true for all the real values of x, which means this quadratic must have real roots. That means the discriminant will be greater than equal to 0, and through that you find its range. Do you remember that method? Give me a quick update in the chat box. Do you remember that? Quadratic upon quadratic, you put it equal to y, and then you solve it. You create it as a quadratic in x, and then you say that this will be having real roots, and that's how you find its range. That's brilliant, Yash. That's really good. With this, I'm moving further with the next part. This is a conclusion which you can remember. Remember this. Let's say you're multiplying two odd functions or two even functions, then this product is always even. It's like negative, negative, positive, positive. It is always positive. Now, there, product of odd and even is odd. It's like, again, that negative into positive is negative. Now, the third one. Every function fx can be expressed as a sum of an even and odd function. Remember this. IDJE has been asking questions based on this property. Sir, how do we do it? Let's say there is a function f of x. I want to express it as a sum of two functions, out of which one of them is even, other one is odd. How do we do that? Now, pay attention to this part. This is given as f of x plus f of minus x divided by 2. That's the even part of it, plus f of x minus f of minus x divided by 2. That's the odd part of it. So this expression, when simplified, will result into this fx only, where this part is the even part and this part is the odd part. Everybody. Great, Ashish. Put it is in the comment box. We'll definitely work on this request. Now, the third conclusion is that derivative of odd is even. I hope you remember that. Derivative of an odd is an even, and the derivative of even is odd. Now, a function which is even or odd, squared becomes even, because even into even, odd into odd, that's even. And the only function which is even and odd is 0. This is something of, you should take a screenshot here. Keep this with you. You will be using it not only in functions, but in definite integration and possibly in area under the curve. You will need it, because when graphs come into picture, this periodicity helps you a lot. So let's say sin x, cos x, sec x, and cosec x. If they are raised to an even power, the period is pi. But if they are raised to an odd power or fraction power, the period is 2 pi. Remember that? Will you all remember that? I hope no confusion on that. But for 10x and cot x, whatever power you raise them to, the period is always pi. If you put a mod over them, the period will be pi. For fraction part is 1. For algebraic, there is no period. But for constant functions, the period is not defined, but they are still periodic. I'm hoping and expecting that you all know these things. Now, when I talk about this conclusion, I'll simply suggest you this thing, that let's say sin x is a periodic function, but if I multiply it and add or subtract a number to it, its period does not get affected. But if I am multiplying the variable inside that periodic function by a certain value, then the new period becomes t by mod c. If I wish to simply define it, it is here that 7 does not affect its period, pi by 9 or minus 12 does not affect its period. But here, if this x is multiplied by 2, now the new period will be 2 pi by mod 2, that is pi. Is this part everyone aware of? Great. Om Sai Ram is saying need to slow down. Okay, so I'll be more slower, but I think this is a revision session. I am hoping that you all are aware of, but still I'll try to slow. So first of all, please understand, let's say there are two functions given to us and their summation or difference is given, and both of the functions are periodic. Then I'm asked to verify whether the summation or difference is a periodic or not. First of all, it will be a periodic. Just need to ensure that whether it's getting converted into an identity or not. What does it mean? Let's say there is a function sin square x. Let's say there is a function sin square x, there is a function cos square x. Now we know sin square x and cos square x both are periodic. So you may say that their LCM will be the period of sin square x plus cos square x, but we know that sin square x plus cos square x is 1. So there is, of course, it is a periodic function. 1 being constant is a periodic function, but it will not have that period, the period which is defined or given by this definition. Then what are you trying to say, sir? We are not getting it. All I'm saying is, let's say there are two functions f of x and g of x. They are periodic. So ensure that it is not getting converted into identity. But if you are getting two functions, then take the LCM of their periods. So LCM of T1 and T2 will be the period of h of x. Did you all get that? I hope you got that. If it is not an even function, but if f1x and f2x are complementary pairwise comparable functions, in that case, the period will be half of LCM of T1 and T2. Will you all remember that? All the participants. Can I move ahead from here? The next thing. This is what you should remember. Let's say I am wanting to take the LCM of pi by 2 and 2. Then of course, you cannot take the LCM of pi by 2 and 2 because pi by 2 is an irrational number, 2 is a rational number. So LCM of irrational and rational cannot be taken. But if I am asked, let's say one of the functions has period as 2 pi by 3, other has pi by 6, the third one has pi by 12. And if they are added, in that case, always remember, the period of summation or difference of these three functions will be LCM of these three periods, which will finally result into a 2 pi by 3. Did you all get that? Or shall I repeat this part? All the participants. Now, with that, I am moving ahead with this next conclusion. Just give me a quick update. I hope the speed is fine. I hope you all can see me properly. I hope there's no problem with the discussion or the pace at which I'm teaching right now. I hope you're okay with that. Can we continue with this discussion? Now, moving ahead from here, let me see what are we doing. So here we are with this LCM of rational and rational. As we have already discussed this part, I think I need not give you clarity on that. Now, number of mappings. Number of mappings means what? Great, great. Thank you so much, gamer. With this, what you need to understand is that, let's say if I am asking you number of mappings, so there is set A, there is set B, set A is domain, set B is codomain. Now from here, set A has m elements, set B has n elements. In that case, number of mappings, if I want to talk about number of mappings, okay, so this gives you that number of mappings means what? Number of 1-1 functions. Number of 1-1 functions, I hope you understand, which means x1 is mapped with one element, x2 is mapped with one element, and so on and so on. So there is no many-one mapping at all. It could be into or onto, that doesn't matter. But if it is a 1-1 mapping, in that case, all you need to do is what? Sir, for these m elements, I need to choose m images out of these n elements. So out of n elements, m images can be chosen in NCM ways. And those pairing can be done in m factorial ways. So NCM into m factorial, is it what? Sir, this is nothing but NPM only. Did you all get that? 1-to-1 mapping from basic permutation and combination. I hope no confusion on that. Now, these are also some general results based on functional definitions, which is very widely asked by JEE Advanced. I repeat, a lot of students are in comments saying that, sir, mathematics is tough. I totally get that and I accept it. But remember this, even if mathematics is tough, you got to score or get the best out of it. You can maximize your score. Sir, how do we do that? By knowing things in depth. JEE Mains was all about speed, but JEE Advanced is all about depth. In-depth conceptual learning, if you have, you can work out a lot of questions. So focus on your strong areas and then attempt or solve those questions only. I hope you remember 35% of the paper can fetch you a rank under 10,000 and 40% of the paper can get you a rank under 5,000. Yes. With this, moving ahead with this, I hope you remember, no confusion on this. F of xy, let's say, is given as f of x plus f of y. If in a question it is mentioned, then don't hesitate in taking f of x as k ln x or 0. But they'll give you in the question that f of x is not 0. Then you will say that f of x will be k ln x. Similarly, if I'm told f of xy is equal to f of x into f of y, then I'll say that f of x is x to the power n. These are the functional definitions you got to take. The third result, f of x plus y, let's say, is given as f of x into f of y, f of x into f of y. Then I'll take f of x as a to the power kx. The next result, if f of x plus y is given as f of x is equal to f of y, then you will say that, sir, that can happen only when f of x is a constant function. Are you all aware of it? If you want the PDF of these notes, you can get it on our WhatsApp channel. They'll be uploaded after the session. Yes, I do remember you. That's great. Good to have you. So yes, if somebody says that f of x takes all the rational values, then don't hesitate in saying f of x takes all the rational values for all x. So let's say in a question it is said that f of x takes all the rational values for all x which are real. It takes all the rational values for all x which are real. So that can happen only when it is a constant function. So if something like that is stated in the question in the JEE Advanced in mathematics section, you got to take it like this. Everybody got this? Can I move ahead from here? Now, general results, transformation of graphs. You will need it not only in definite integration, but also in your transformation of graphs, that is where area under the curve come into the picture. So there, if area under the curve comes into picture, I hope you remember this result very clearly. Let's say if this is the graph of e to the power x, if 1 is added, the graph is shifted 1 unit above. If 1 is subtracted, the graph is shifted 1 unit below. Do you remember that? Next part, if let's say this is the graph of mod of x, if I'm subtracting 1 from it, the graph is shifted 1 unit on the right hand side on the x-axis, along the x-axis. But if I'm adding 1 to it, the graph is shifted 1 unit left along the x-axis. Everybody got this? Everybody understood this? Now from here, when I go ahead, the next result, let's say I am given the graph of sin x. This is the graph of sin x, standard graph. But let's say I am multiplying sin x by 2. I am multiplying sin x by 2. So it gets stretched, which means its range, instead of from -1 to 1, will now be from -2 to 2. I hope you remember these transformation of graphs. From here, the next part, let's say I am now dividing, let's say that there is a graph of sin x, and then I am willing to draw the graph of sin 2x. In that case, it will get compressed along the x-axis. Did you all get that? Are you all aware of these basics? With this, something very important and crucial, let's say you're given the graph of f of x, and then you want to draw the graph of f of minus x. Sir, how do we do that? Simply do nothing but take the mirror image of f of x in the y-axis. You will get the graph of f of minus x. Everybody aware of that? Everybody knows that? From here, the next part, sir, how do we draw the graph of minus of f of x if the graph of f of x is given? I hope you remember, you need to do nothing but simply, let's say you are given the graph of f of x, you take its mirror image, in the x-axis, that is the graph of minus of f of x. Are you all aware of it? Now, sir, the next result, sir, how do we draw the graph of mod of f of x? Mod of f of x means what? The portion which is below the x-axis should not exist. So here, let's say this here is the graph of f of x. So this is the portion which is below the x-axis, which means here f of x is negative. So that part's mirror image is what you take. This part which is below the x-axis, its mirror image you take and you remove this part, and there you draw the graph of mod of f of x. The next conclusion, this is the graph of log of x for a while. There is a difference, of course. Then let's say I want to draw the graph of log of mod of x, which means let's say I want to draw the graph of f of mod of x from the graph of f of x. In that case, what you do? Simply do nothing but remove the portion of the graph which is there on the left hand side of the x-axis, which is there on the left hand side of the y-axis, and just take the mirror image of this portion which is on the right hand side of the x-axis in with respect to the y-axis. There you are in a position to draw the graph of f of mod of x. Everybody got that? Now, how do we apply the L'Hopital rule? L'Hopital rules, I hope you all are aware of. If there is a 0 by 0 or infinity by infinity form, we differentiate numerator and denominator separately, and that's how we apply L'Hopital. These are some standard expansions I want you all to remember. Because you'll be applying these expansions in the questions and you'll be fetching the answers directly. Yes, first one, if I talk about e to the power x, we all have mugged it up a lot many times. For a to the power x, it becomes x log a, x log a, x log a, square, cubed and all. And with this 1 plus x to the power n, you already know it, the binomial expansion. But when I talk about log 1 plus x, there, the expansion goes like this: x minus x square by 2 plus x cube by 3 and so on. For this also, I hope you must have been remembering this general result, x to the power n minus a to the power n upon x minus a. From here, I hope these results also are very well understood by you. Sin x being the odd function will always have all the odd powers. Cos x being the even function will always have the even powers. I hope you'll remember these expansions because they are directly used in questions based on limits, continuity and differentiability. I hope you remember that. I will definitely help you with that part as well. Don't worry about that. I hope you can keep all these pages with you when you're doing the final revision. We'll definitely be doing that. Sir, when is JEE Advanced? That's a very good question, IITian. Now, this is another formula which you, I hope, must have been keeping at your fingertips. These are again some general results. You must have been using them. Sin x upon x when x approaches 0, tan x upon x and all of these. But one catch is here that sin x degree upon x when x approaches 0 is not 1. But here you got to convert this x radian also into degrees. And to make that adjustment, you introduce pi by 180 there. Sir, any trick to remember 10x expansion? No, but I will say that 10x expansion, they would not be asking more than these three values. So at least these three elements you should remember. These three elements you should remember. And that comes with practice. Right now, I am not in a position to suggest you any trick unnecessarily. It will confuse you. Simply try to learn them. Sir, do we have this PDF? Yes, you can have this PDF. How can you have this PDF? By following our WhatsApp channel. After the session, we'll be uploading it there. Now the next portion. I hope you remember, if fx and gx both are approaching 0 when x approaches 0, then we remember 1 plus f of x raised to the power 1 by g of x is technically 1 to the power infinity form. And for that, the solution is given by e to the power x approaches a fx upon gx. Technically, you subtract 1 from the base and you multiply it with the power. Do you all remember that? Do you all remember that? With this, I hope I can move ahead with the next discussion. Some particular cases of 1 to the power infinity form, you can get these direct results. But if you can remember that the moment you encounter 1 plus x to the power 1 by x or 1 plus 1 by x to the power x, when x approaches 0 in the first case and when x approaches infinity in the second case, in that case, Om Sai Ram Enterprise, you don't have to write. That's exactly what I'm saying. That here, all of these notes in the PDF format will be given to you at free of cost on our WhatsApp channel after the session. So don't take down the notes. In that case, you can get it done from someone else. Any friend of yours can do it. Okay, great. You will. It's not a group, it's a channel, Bhumika. There you'll get it. I think if it's a group, it's a fake one. We did not create it. We don't have any group. We don't have any WhatsApp group. We have a WhatsApp channel. So, yes, there is an extra class, Rudra, in the morning at 11 for Laksh batch. Now, this is something where students commit a lot of mistakes. I want you all to pay attention to this part. This is where JEE Advanced comes into picture. They want to check your basic understanding, the core level understanding, the nuances. How do we learn that? Remember it. Sin x upon x approaches 1 from the left hand side. That is 0.99, 0.98 and so on. That means what? That means if you are taking limit x approaches 0, GIF of sin x upon x, what it would be? It would be 0. But let's say you are talking about 10x upon x and if GIF is given over it. So in that case, when you take GIF over 10x upon x when x approaches 0, it will be approaching 1 because 10x upon x approaches 1 from the right hand side. That is 1.1, 1.001 and so on. For Arjuna JEE, I am not talking about anything. You stay there on this channel only. At 6 o'clock in the evening, we'll be launching or coming up with an excellent surprise. But for all the students in the Laksh 12th class JEE aspirants, tomorrow there is an extra class of mathematics. Now, coming back to the discussion for all the JEE aspirants we are having right now, this is not L'Hopital. This is now your Newton-Leibniz formula. Do you remember that? An amazing one. A very insightful one, which is not only used in definite integration, but they use it in differential equations. And of course, they use it in limits, continuity, and differentiability based questions as well. Sir, how is it applied? I hope you do remember that. Let's say phi x to psi x ft dt. So of course, this is a function of x because finally when you integrate it with respect to t, put the upper limit and lower limit, it will be a function of x. So instead of integrating it first and then differentiating it, what I can do here is I can apply Newton-Leibniz directly. If I want to differentiate a definite integration, how do I do it? I will first of all put the upper limit into this and then differentiate the upper limit, minus put the lower limit into this and then differentiate the lower limit. I hope you must have been practicing this formula lately a lot many times. Give me a quick update. I hope I'm not being very fast. I'm of course speaking at a little faster pace than my usual speed, but that's what I'm doing because you know all of these formulas. Just a quick recap, the glimpse I'm trying to give you here in this video. So everybody with me on this. So far, there is no confusion on whatever we are discussing here. The next part, this limit as a sum. I hope you remember, all we need to do is that if I'm given a limit-based question, which could be done with, let's say, sandwich theorem, but if you are able to do it with the help of the summation formula, getting converted into an expression somewhat like a function in R by N, where n approaches infinity, 1 by x in summation is given, then we can convert it into a question of definite integration. People are saying, go a little bit slow. Okay. So far I was assuming that you already know these, but let me speak at a little slower pace. Okay, I get this. Again, Those people who are saying that they need the PDF of this session, I'm constantly telling you that link is given in the description of our WhatsApp channel. It's not WhatsApp group. You can go there, and on WhatsApp channel after this session, we'll be uploading our PDF. Don't worry about that. Coming back to the discussion here, this R by N always gets replaced by X. Please remember that. This 1 by X should be replaced by dx. This 1 by X should be replaced by dx. And then, of course, this phi x when replaced in place of r, that means phi x by n. Phi x by n and psi x by n are the lower limit and upper limit respectively. And that's how you convert this summation expression into a question of definite integration. I hope no confusion on that. We will be uploading that, Dhanshri. Don't worry about that. We'll be uploading that. Whatever lectures notes you have not received, mention them here in the comment, not in this live chat, in the comment of this video. I'll be getting or ensuring that all the notes are uploaded. It's my promise and assurance to you. Once the session gets over, I'll get all those notes uploaded. Don't worry about that. I promise you. Now, with this, the theorems on continuity and differentiability, do you remember that? Sum, difference, product, and quotient of two continuous functions is always continuous, given the denominator is not zero in case of division. I hope you remember that. I hope you remember that. There is no WhatsApp group, Rudra. Why are you not getting it? We don't have any official group here. If you are a part of any PWJ English WhatsApp group, it is a fake one. We have our channel. We have our channel, PWJ English. The link is given in the description. Now, if a function is continuous, other is discontinuous, then the product is not necessarily be discontinuous. Remember that. Continuous into discontinuous could be continuous or discontinuous. You cannot put any comment. But the interesting part here is that let's say fx is differentiable at a and f of a is 0. Fx is differentiable at a and f of a is 0. Gx is continuous at a. Then fx into gx will be differentiable at a. Please remember this as a fact. Direct questions are asked on this property. Student waste a lot of time in developing them. They directly can apply this property and get a lot of questions done. I repeat, what did I say? There are two functions, f of x and g of x, and their products differentiability is what I need to assess. But what I know here is that, sir, let's say this function is differentiable, this function is differentiable, and this function at a is 0, and this function is continuous at a. This function is continuous at a, and this f of x is differentiable at a. In that case, without even knowing or checking the differentiability of g of x at a, I can claim that this product f of x into gx will be differentiable at a. Did you all get this? Did you all get this, or shall I repeat this? Bhumika, I told you we will upload it if there are no PDFs. Just mention the lectures which you are not getting, the PDFs you are not getting. The second result is that through derivatives, you can talk about approximation as well. Do you remember that? Let me give you a straightforward example here. I hope you do remember that. Let's say I want to find the approximate value of under root 101. I want to find the approximate value of 101, under root 101. So here, what I do is, I'll first of all define a function f of x, which is under root x. F dash x is this. So there, the formula says that f of x plus delta x minus f of x is f dash x minus delta x. I'm constantly asking you to keep this formula at your fingertips. Let's say, if there's a question based on finding the approximate value of an expression, you'll be using it. Flow of the session is really simple. We have started with calculus, then we'll probably move towards vectors, then algebra, then trigo, and then ultimately in the end we'll conclude it with the coordinate geometry. With this, I hope if you apply this formula, under root 101 minus under root 100 will be derivative of under root x at 101 at 100 into delta x. Delta x is the difference between 101 and 100, so that is 1. F dash x is derivative of under root x at x is equals to 100, and that expression finally gives you the value of under root 101, the approximate value. I hope this formula is self-evident here. Now, geometrical application of tangent we all know, of derivative we all know, that if we want to find the slope of the tangent. So if there is a function at which there is a point x1 comma y1, so if I differentiate it and if I in that derivative replace x1 by x1 and y1, I'll find its slope through the tangent, which means I'll find the tan theta there. That is m. I hope you're aware of it. No confusion, no clarity is needed to be given on that. But there is a shortcut as well. I hope most of you are already aware of that. If you write t is equal to 0, this works for a second degree equation only. So if there is a second degree equation, in two variables, if there is a second degree equation in two variables, let's say ax square plus 2hxy plus by square plus 2gx plus 2y plus c, then of course it could mean either a circle or parabola or ellipse or hyperbola. Then if I wish to write the equation of tangent to this second degree curve at any point lying on it, how do we do that? Do you remember that? I hope you remember this thing very clearly, that there x square should be replaced by xx1, y square should be replaced by yy1, x should be replaced by x plus x1 by 2, y should be replaced by y plus y1 by 2, and if there is a term in xy, it should be replaced by xy1 plus x1y by 2. If you are doing this, you can directly write the equation of the tangent, and it is called t is equal to 0. How many of you are aware of it already? Give me a quick update on this in the chat box. Are you all aware of it? Did you already know it? Now from here, the next part. Let's say I'm given two curves and I want to find the angle between these two curves. Angle between these two curves means what? If there is a question based on it asked, what you do here is pay attention to this part. Let's say you draw a tangent here at this point of intersection, you draw another tangent here at this point of intersection. So the angle between these two curves, where they intersect, the angle between these two curves means the point at which they are intersecting, I'm drawing two tangents, and the angle between those two tangents is nothing but the angle between those two curves. I hope you remember, if this theta is needed to be found, if I know the slope of this line, if I know the slope of this line, I can do it with m1 minus m2 upon 1 plus m1 m2, that is tan theta between two straight lines. Do you remember that? And there m1 and m2 with derivatives we know is nothing but what? Dy by dx. So I'll find this point of intersection. I'll find the derivative of first function and second function. In first function I'll put that x1 y1, m1 I'll have. In second function I'll put that x2 y2. In second function's derivative I'll put x1 y1. I'll find m2, and with this I'll get the formula. How many of you get this? Everybody understood this? All the participants? With this is how you define the concept of maxima and minima. I think you are already aware of it. Few things if you want to take care of, let me take you through that. Whenever a function is decreasing, f dash x is negative. Whenever a function is increasing, f dash x is positive. If I am seeing global maxima, of course f dash x will be 0. And at all the critical points, the maximum value of that expression f of x will be the global maxima. At all the critical points, the minimum value of that expression f of x will be my global minima. And not at all these points, the critical points, that is when f dash x becomes 0, I'll be having local maxima or local minima or global maxima or global minima. And of course there are certain points where you see a sharp turns, and there of course if it is a sharp turn, then we say that the derivative is not defined here, the function is non-differentiable here. Everybody aware of all these basics, all these nuances? Now there comes another part. We know this, that if f of x is strictly increasing, then f inverse x is also strictly increasing. Remember this as a fact. Next is, let's say, pay attention to this part. fx and gx have the same monotonicity, which means either both of them are increasing or both of them are decreasing. Then remember this as a fact. In that case, their composite will be increasing. I repeat, if both of them are increasing, composite will be increasing. If both of them are decreasing also, then their composite will be increasing. I hope you will remember this as a fact. Sir, you are putting a lot of information, you are passing down a lot of information. How are we going to remember all of this? I'll simply say, do one thing. After the session, this PDF is yours, totally yours at no cost. Then you can revise it from this PDF, all of these things, right? I'm highlighting a lot of details. So you don't have to go through the entire PDF. Just go through the highlighted points, which are the most crucial ones, which are a lot many times are the ones which are avoided by students usually. The next result, fx and gx have opposite monotony, which means what? Monotonicity, which means fx is increasing, gx is decreasing, or fx is decreasing, gx is increasing. In that case, their composite is strictly decreasing. I repeat, if one of them is increasing, other one is decreasing, then their composite will be decreasing. Did you all understand this? Shall I move ahead from here? And yes, inverse of a continuous is continuous. Please remember that. Now, nth derivative test you already are aware of. You must have done it in physics as well, so I need not give you. When I want to find out the global maxima or global minima, So first of all, I find f dash x is equal to 0. Through that, I find critical points C1, C2, C3 I get. And I'll find all these values f of a, f of b, f of c1, f of c2 and all. And why am I finding f of a and f of b? Because they are the boundary conditions. I hope you remember that. So among all of these values, whichever is the least value, that will be our global minima. Among all these values, whichever is the greatest value will be our global maxima. AK Gamer, I got your concern. In the comment box, not in this live chat, after the session, put it as a reminder that you want the session, the same session for physics and chemistry as well. Will ensure that such sessions are conducted for physics and chemistry as well. Don't worry about that. Now here, these are the formulae of integration. I need not give you clarity on that. Some things if I could highlight, I'll be highlighting the most important ones. I hope this one, where you say that's our integration of 10x in cot x. I hope you remember for 10x it is minus of log of mod of cos x, and for cot x it is mod of log of mod of sin x. It is clearly getting derived with this chain formula, or with this eilate integration by parts also you can derive it. The next conclusions. I hope all of these formulas you must have been practicing. But students do get confused here. Even in our live classes also, a lot of students were asking about these doubts. First of all, remember, let's say I'm integrating 1 upon a square plus x square. Then of course it is 1 upon a tan inverse x upon a. But if you're integrating 1 upon under root a square minus x square, then it is not 1 upon a sin inverse x upon a. It is simply sin inverse x upon a. So please don't commit that mistake. This is the mistake students commit a lot lately. They have been doing it. I hope you'll remember these facts. Now with this is something really simple and doable. If x is multiplied by a value, then its integral will have that a in the denominator. And if same is there, if there is this denominator in the denominator, then you simply take the log of it. Why are we discussing these trigonometric identities here when we are talking about integration? Because in integration, we of course face a lot of difficulties while applying the product formula, that is eilate integration by parts. So if I could convert that product into sum, I'll be in a very good position to get my answers out. So I hope you remember sin A cos B, cos A sin B, for which you need not remember two formulae. One formula is sufficient, but sin A sin B, cos A cos B. For that, I hope three formulae you got to keep at your fingertips, which you must have been practicing since your 11th standard. So these versions, we are getting confused. Forget that. Do you remember 2 sin A cos B? Do you remember 2 cos A cos B? Do you remember 2 sin A sin B? I hope you remember them from sin A plus B plus sin A minus B, sin A plus B minus sin A minus B, cos A plus B plus cos A minus B, cos A minus B minus cos A plus B. I hope you these four formulae you must have been studying. That's exactly what are written over here. Now with that, I'm moving ahead with this. These are the special integrals which you cannot afford to miss, because if integration is asked, they'll definitely be asking questions based on these special integrals, which means what? Of course, this is what we have already studied. But if it is x square minus a square, you won't be having the time to derive it in the real examination hall. So I'm suggesting you learn them, you memorize them, and you keep them at your fingertips so that you can apply directly them in the real examination hall and you can get the answers quickly. I hope you're getting it. So if right now you still have the time to learn it, learn them. 1 upon x square minus a square, 1 by 2a log x by x minus a, x plus a inside the mod. Whenever log is there, you put a mod. A square minus x square, it is same 1 by 2a, but here in the numerator, it will be a plus x, denominator, it will be a minus x. Sir, how are these formulae derived? With these substitutions. Now, if it is under root a square minus a square, x square, then of course sin inverse. But if it is under root a square plus x square, then it is log of x plus under root x square plus a square. Similarly, there are some more. There are technically few more. These 4 more. Under root x square minus a square inside a denominator will give you this, which is same as what we have discussed when it was x square plus a square. And these three, they will not just be used in questions based on indefinite integration, but you will be needing them in definite integration, in area under the curve. In yesterday's session only, we have discussed this point. I like KKR the most. Now we'll have a debate going on that. Sir, how are all these formulae derived? With the help of these substitutions. So let's say in case you forget one of the formulae, you can derive them. But in the examination hall, avoid deriving something new. I hope you got this. Now with this, sir, how to deal with integrals when you have quadratic. So 1 upon quadratic, 1 upon under root over quadratic, or under root over a quadratic. You convert it into a perfect square. So it will be under root over a square plus x square, under root over a square minus x square, or 1 upon under root over a square plus x square. Or all of these variants will get created. And for all of these variants, we had a discussion that how do you build the formulae. So I hope I did not explain this slide, and I hope I'm not teaching too fast. I hope my speed is fine. Definitely this can help you in CUET, but that is very easy compared to JEE Advanced. But this will definitely help you if you are taking this and revising it. And you can have this PDF through our WhatsApp channel. Now, this part, linear upon quadratic, linear upon under root over quadratic, linear into under root over quadratic. There all you need to do is simply do this, that linear should be represented as derivative of quadratic into a constant, arbitrary constant, plus that another constant. And with that, when you do this, you will straight away start seeing what is needed to be done. I am assuring you, but only thing you need to remember is this conversion. When a linear and quadratic is given, express that linear as this derivative of quadratic into lambda plus mu, and you will get your answer within seconds. Sir, what to do when you have a polynomial which is more than a quadratic in the numerator upon quadratic? Then you divide it first. Then I did not get your concern, odd one. Yes. Now, all I'm saying is that cubic upon quadratic or biquadratic upon quadratic, which means what? First of all, you divide it and then you do it. I hope you have understood this part. Then, sir, what if quadratic upon quadratic, or quadratic upon under root over quadratic, or quadratic into under root over quadratic? In that case, the funda is really simple. You got to apply this arrangement. What does it say? Sir, that quadratic, the other quadratic, which is there in the numerator or which is there outside the under root sign, that should be represented as lambda times that quadratic plus mu times derivative of that quadratic plus gamma. And with that, again, you will be in a position to find out the integral. Just remember that. Sir, what to do when we deal with cos square x and sin square x or any other combination of it? In that case, simply do this thing. Divide numerator and denominator both by cos square x. You will see terms in tan square x and sec square x. And for that, you know what to do. Tan x as t, sec square dx dt, and the job will be done. With multiple correct Nandita, I'll say, let's say there are 4 options, A, B, and C. There are 4 options, A, B, C, D, right? And out of this, there are 3 options correct, A, B, and D. But you have cracked that A and B are correct. But your estimation have told you that A and B are correct. And you're confused between C and D. So don't go ahead with that, because if you're marking these A and B correctly, you'll get the partial marking, although you'll not get the full marks, but still you're getting partial marking. But if you're taking a risk on D, whether you know it or not, and let's say you've incorrectly marked C, then you will lose all the marks and you'll go with -2. So I hope you're understanding this partial marking of these two was way better than an entire negative marking now. So that's the difference there with multiple option correct. Please take care of that. Now with this conclusion, when linear and sin x and cos x are given, I hope in the beginning of this session only, I gave you 2 formulae, sin 2x and cos 2x in terms of tan. If you remember them, you got to apply them. Sin 2 theta is 2 tan theta upon 1 plus tan square theta, and cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. If you apply those 2 versions here, your integral will be resolved. Now, with this, I'm moving towards the next part. Sir, linear in sin x upon cos x in the numerator and denominator both. Again, the same funda you got to apply. What is that funda? Pay attention that here, numerator, you write as lambda times denominator plus mu times derivative of denominator plus gamma. And of course, again, what your job will be done. I'll say all the chapters. More importantly, the chapters which you are good at. With these 7-8 days left, I'll say focus on what you all are already good at. Now, from here, we have already discussed all of this. I think we can move ahead. Integration by parts you already know. I think what IIT JEE is madly in love with is this formula. I hope you remember it. Sum of 2 functions where one function is the derivative of other is getting multiplied by e to the power x. So integral is always e to the power x fx. Do you all know that? With this, let's say sometimes you are dealing with an integral where it is 1 plus 1 by x square kind of an integral, but there you are seeing an expression is x minus 1 by x as well. I repeat, there what are we given? A function in x minus 1 by x, or if I could convert it into a function of x minus 1 by x, and there I'm getting or seeing 1 plus 1 by x square as well. So I hope you remember, if I substitute x minus 1 by x as t, then I'll have 1 plus 1 by x square dx as dt. So it will become ft dt, which is doable. I hope you got my point. The same you can do with these when you're dealing with biquadratics. There you got to apply this result. You divide it by x square and you get something like this, and you get that result, what I'm asking you to do or apply here. The next one is Wally's formula. Now, how do we talk about this Wally's formula? I'll simply say that, let's say you are given sine x to the power m, cos x to the power n. In that case, just keep these points in your mind. What do I mean by that? Sir, if m and n both are natural numbers, and then let's say if one of them is odd, then substitute for terms of even power. I repeat, substitute the terms of the even power. The second one is if both are odd, then substitute either of them. If both are even, then use identities. And if m and n are rational numbers, then check whether m plus n minus 2 by 2 is a negative integer or not. In that case, substitute cot x as p. So these are a lot of formulae. Are we going to remember them? Of course not. But try to remember as many as you can. I'm just giving you a complete list of formulae which you should go with before your JEE Advanced from mathematics section. So this session is covering that. And after this session, I'm assuring you this entire PDF will be uploaded. This is again a formula which you can verify or validate by yourself. And of course, there are certain cases, instead of reading it out aloud, you can read it by yourself when you refer the PDF. This particular part, King's property, you are aware of. I need not explain that. Are you all aware of King's property? And then King's property's corollary is there. And this version of odd and even, you must have been doing it a lot many times. Minus a to a, it becomes 0 if it is odd, 2 times f of x if it is even. And then of course, this is another version of that even and odd property. And there you deal with the periodic functions as well. I hope you remember this part. F of x dx 0 to nt is n times 0 to t, and other versions of it. And this particular part, this property or formula or value is directly used in a lot of questions. What does it say? It says log of sine x from 0 to pi by 2 or log of cos x from 0 to pi by 2 is always pi by 2 log 2. You don't have to derive it. If you remember this result directly, you will be applying it in questions directly. So please remember it. Please remember it. From here, the next few results based on properties only. I hope you remember splitting of a limit. Of course, there also you are seeing it. It is a plus nt. Let me correct that. It is a plus nt to b plus nt. Then of course it is periodic. There I'll say it is a to b f of x dx. This is something which is used to find the maximum or minimum of a definite integral. Let's say f of x has minimum value as small m. So small m is its minimum value. F of x has maximum value as capital M. So capital M is the maximum value, minimum value is a small m. So if I multiply small m by b minus a, if I multiply capital M by b minus a, that will be the least and the largest value of that definite integral. So let's say in a question in JEE Advanced, I have to find the range of a definite integral. Yes, that is needed. So how do we do that? I simply use this. Did you all get this? Definitely. AK Gamer, in this week, we are coming up with those sessions only. We have already planned them. Don't worry about that. We are bringing those sessions. With this is again definite integration based properties. This is called Wally's formula. Wally was a mathematician and he developed it. It is either Wally's or Wall apostrophe s, whatever it is. I don't know his name properly. I'm really sorry for that. But here, if you are given 0 to pi by 2 sin x cos x raised to the power m and n respectively, you don't have to go through the entire integration problem. For that, I have already released a video on our channel. On PWJ English for BitSat, I have already released a strategy video. You go through that video. I have discussed everything in a very detailed format. I repeat, the Music Symphony India. For BitSat, I have already given a video on our channel. Go through that. Now, what does Wally's formula say? If here both m and n are even, if both m and n are even, in that case, this expression has answer as m minus 1, m minus 3 and so on until 1 or 2. Then n minus 3, n minus 1 until 1 or 2 divided by m plus n minus 2 and so on. What are you saying, sir? We don't get this. I am saying that, let's say I am asked sine x to the power 4 cos x to the power 6 dx, and the limit you should ensure is from 0 to pi by 2. So you don't have to integrate it. Wally's formula give you the direct shortcut here. It says that the answer here will be m minus n. What is it? Sir, m is 4. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. You stop there. Into 6 minus 3. I'm really sorry. It should be 6 minus 1 here, first of all. So 6 minus 1 is 5. 5 minus, I hope you're understanding it now. You keep subtracting 2. I'm really sorry. There's some confusion here. Let me do it one more time. Pay attention to this part. M and N both are even. I hope you're paying attention to it. So M minus 1, M minus 3 and so on. And there also N minus 1, N minus 3. So you keep subtracting 2 technically. I'm really sorry for that. So M minus 1 means what? 4 minus 1, that is 3. 3 minus 2 is 1 into 6 minus 5. 5 minus 2 is 3. 3 minus 2 is 1. You stop at 1. Then divided by M plus N. 4 plus 6 is 10. 10 minus 1. What is 10 minus 1? First of all, write 10. Then 10 minus 2, that is 8 and so on until again 1 or 2. And there you stop at 2 and then you multiply it by pi by 2. If it is an even, both are even. But if either of them is odd, in that case, you don't append a pi by 2. That's the only difference. I hope you got this. So you can directly apply this result and write the final answer. Exact differential equations are those kind of equations that if you could observe that in your question, exact differential equation is being used, then instead of linear or homogeneous or variable separable form, you could see this pattern directly and apply it and get the result. What does it mean? I hope you remember that xy, x dy, y dx is dxy, dxy. Similarly, all of these results are there, which you can see, learn, memorize, and revise. Now, we'll be talking about vectors in 3D. Everybody clear with whatever we have discussed about calculus? Now, with vectors in 3D, of course, we know that if there is a point which has direction cosines as L, M, and N, and if its distance from origin is R, then its coordinates will be LR, MR, and NR. I hope I'm not proving it. I need not prove it. But if there is a point whose direction ratios are A, B, C, but let's say the sum of their squares is 1, which means A square, B square plus C square is 1, then instead of calling them the direction ratios, I will unhesitatingly call them the direction cosines. Did you all get that? From here, the next part. Let's say there is a triangle whose vertices are ABC, position vectors are ABC. In that case, its centroid will be given by A plus B plus C by 3. Everybody getting that? And in center, orthocenter and circumcenter can also be defined. For in center, I hope you remember BC. What is BC? The distance. So vertex A has opposite side BC. So that distance into this AC into B. So AC is the side which is opposite to the vertex A. AB into C. So this is your AB which has vertex C as opposite to it, divided by AB plus BC plus CA. The same formula you must have studied in coordinate geometry as well. So that same formula is getting extended in vectors in 3D. Similarly, the same you get apply for orthocenter and circumcenter. For ortho, 10 come into picture, and for circum, sine 2a comes into picture. I hope no confusion on these formulae. But more importantly, I'll ask you to remember at least this one, which is for centroid. Now, one thing, let's say there are two vectors. Let's say there are two vectors, A and B. You want to find the internal angle bisector and external angle bisector. So for internal angle bisector, it is always, this is your vector A, this is your vector B. The internal angle bisector is mu times A cap plus B cap. I'm not giving you the proof, just remember it as a fact. The external angle bisector will be mu times A cap minus B cap. Why? Because you create a rhombus, unit vector here, unit vector there, rhombus. So that rhombus diagonal divides it equally in terms of angle. So that's why A cap plus B cap will be the internal angle. A cap minus B cap will be the external angle bisector. And if I multiply it by some scalar quantity, it will give me its length. Please upload a lecture on graphing. I like your way of teaching. Pretty sure it will help me in others. Definitely. I'll try to create one. I got your point. Just put it in the comment box, not in this live chat. I'll definitely create one. Now from here, I hope you all clearly are aware of that 3 points are with these position vectors, and if they are collinear, this will be true. This is what we have already studied in 2D, so I hope I did not give you clarity on that. Now this is where we talk about these properties. Something very crucial you should understand, that cos theta lies between -1 and 1. So dot of two vectors will always be less than mod A mod B, right? Other than that, I think you all already are aware of. This is the projection formula. Yes, you got to remember it. Let's say I want to write the projection of A on B. So this is vector A, this is vector B. So projection of A on B, I hope this length is given by A dot B upon mod B. Everybody knows it. I hope no confusion on that. Angle between two vectors. So A1, B1, C1, A2, B2, C2, or rather A1, A2, A3, B1, B2, B3. So this is how you find the angle between two vectors. Dot of them divided by magnitudes of each of them. Are you all aware of it? Everybody. I hope I'm not teaching too fast. You're able to digest and comprehend whatever is being said. Now, with this, I'm moving towards the next part. Pay attention to this part, students. I hope you know mod of a plus b whole square. We simply apply this identity here. These are other versions of it. The one more important crucial part of it I want you all to remember is this, that let's say if somebody says mod of a plus b is equal to mod of a minus b, then you can always conclude that a and b are perpendicular. Why? Because when I square this and when I square this, I'll say a dot b will be found to be 0. And if a dot b is found to be 0, we conclude that a is perpendicular to b. Now the next conclusion, this is something really understood by you all. I need not give you clarity on that. Cross product is something where a lot of students commit mistake. First of all, of course, we don't know that we cannot commute with cross. You all know that. But if I want to swap the order, I'll put a negative sign, which means a cross b is equal to minus b cross a. Do you all know that? Then, of course, this vector product is not associative. I hope you remember that. And then with scalar, it is fine. So m can be pushed either with a or b or both, like this. I hope no confusion on that. From here, the way we do it with matrices, the same will do it with vectors. Let's say if there is cross product. So a cross b plus c. So this is pre-multiplication by a. So that should maintain here. Distribution is allowed with addition or subtraction, but that pre or post should be maintained. I hope you're getting it. That's exactly what we are trying to say here. Now, this conclusion is used very widely in vectors in 3D. What is that? Let's say if somebody says a cross b is 0. If somebody says a cross b is 0, what we know is that a and b are parallel. They are non-zero vectors given, then a and b are parallel. And then we write a is lambda b. I hope this particular one you use at a lot of places and a lot many times. Sir, can we have this PDF after the session? Yes, at absolutely free of cost by simply following our WhatsApp channel, and there we'll be uploading this PDF and you can have it. Sir, how do we access the WhatsApp channel? The link is given in the description. This is again one of the most crucial properties you've got to remember. Lagrange's identity, what does it say? Remember it. What is a cross b? Mod a mod b sine theta. What is a dot b? Mod a mod b cos theta. So I hope you remember sine square theta plus cos square theta becomes 1, and then you're left with mod a square mod b square. So please remember that. Why are you asking that, Advik? I did not get that. It will possibly be same, but in paper 1 and paper 2, they'll change few things. Let's say in paper 1, you're getting numerical, integer type. So in paper 2, you will be getting multiple select, where more than one options are correct. So this is how, let's say in paper 1, they don't introduce matrix match type. So they may surprise you with matrix match type in paper 2. So that's what they do. So that is how you should be prepared for. One thing I can assist you or guide you with this is a simple fact that when you are attempting paper 2, then the gap which you get between paper 1 and paper 2, utilize it for taking rest, for taking a nap. Even if you are not sleeping, rest. Don't start discussing answers, because if you start discussing the answers, you will fall into a negative loop where you will be more depressed. So that gap which is there between paper 1 and paper 2, a lot of students don't perform to the best of their capability or capacity because they are tired, because they are exhausted. So if you are well prepared, trust me, paper 2 is a game of endurance, is a game of stamina. So there you need to be more charged up. So that gap you should utilize wisely. Don't discuss questions, don't discuss answers. Take this gap as an opportunity to let your body recover, to let your body get charged. Now, coming back to this discussion, pay attention to this part here. I think Lagrange's identity is what we have just discussed. When you are willing to take the cross product, as we already know, a cross b in terms of component forms can be found by this. We use it a lot many times, especially with the shortest distance formula. Do you all remember that? With this, when I move ahead, the next conclusion here is, this is one of the most important slides. Let's say there is a parallelogram which has adjacent sides as A and B. So A cross B will give you the area of the parallelogram. Sir, let's say we are given the diagonals of that parallelogram. In that case, half of D1 cross D2 will also give you the area of the parallelogram. The third conclusion, sir, there is a quadrilateral, and it has, quadrilateral means any quadrilateral, not necessarily a parallelogram or a trapezium or any quadrilateral. And I know it's diagonals. In that case, AC cross BD, cross, I hope you're understanding it, cross product. and its magnitude's half will give me the area of any quadrilateral in 3D. And if I want to have the area of any triangle, it's simply half of A cross B. So parallelogram, it is A cross B. For triangle, it is half of A cross B. Yes, it is different. So we cannot compare it because students get changed there. I hope distance formula you already know. This is something I want to talk about here. Pay attention to this part. Let's say there is this straight line which is formed by joining x1, y1, z1 and x2, y2, z2. I hope you are paying attention to that. And let's say there is a plane. Let's say there is a plane. Let's say there is a plane, and this plane is dividing this line segment into a ratio lambda is to 1. Into a ratio lambda is to 1. I should have written lambda here and 1 here. So this plane is dividing this line segment into the ratio lambda is to 1. So that lambda is to 1, you can directly find with the help of this short formula. One of the approaches is what? Sir, I find lambda is to 1. I define this as P, I define this as Q, and I define this as R. So R can be written parametrically. Lambda times Q plus 1 times P divided by lambda plus 1 will be the coordinates of R. Then I put the coordinates of R in this equation of the plane. There I find lambda, and then by putting lambda, I get the coordinates of R. You don't have to do all of this. What do you mean by this? I want to say a simple fact here. Pay attention to this part, students, that here you just got to apply this formula, which we have learned in 2D as well. So what is this formula? It says power of that point with respect to the plane divided by power of that point with respect to the plane. Power of first point with respect to the plane divided by power of second point with respect to the plane, and you take a negative of it. That's nothing but your ratio lambda is to 1. Isn't it interesting, beautiful, and amazing that you can get the answer within seconds instead of putting that much efforts, which we have usually been doing? So I'm asking you to keep it at your fingertips. If you are asked to figure out the ratio in which a plane is dividing the line segment created by joining 2 points, you can use this part. Everybody got that? Now from here, I hope this is what you already know. I need not give you clarity on that. The angle between two lines, if the direction cosines are L1, M1, M1, L2, M2, N2, then we know this formula. I hope you all know that, clearly know that. From here, this is the most interesting part. If two lines are parallel, they'll be proportional, their direction cosines. And if two lines are perpendicular, L1, L2, M1, M2, N1, N2 sum will be 0. The same can be done with direction ratios as well, but I hope you know the change which is brought here. Now, this is the interesting part. The equation of a straight line in vectors. How is it getting created? x1, y1, z1 is the point through which the line is passing, and it is parallel to a cap, b cap, c cap. That means the direction ratios of that line is a, b, c. Sorry, a cap, b cap, c cap. No, it is not a, b, c, which means x2 minus x1, y2 minus y1, z2 minus z1 are your a, b, c. So what does it mean? It means that its equation is given by x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, and z minus z1 upon z2 minus z1. And if I put it equal to lambda, I can define a point parametrically on this line. The same we actually do in 2D. Great. I'll do it. What exactly are you asking, Om Sai Ram? I did not get your comment. I did not get your query. What exactly are you asking for? Now with this, I hope no confusion on whatever we have discussed. The next part, if two lines are perpendicular, of course, I hope you remember that, let's say the first line is R is equal to A1 plus lambda B1. The second line is R is equal to A2 plus mu B2. Then of course, these lines are parallel to B1 and B2. So if the dot of B1 and B2 is 0, that means the lines are perpendicular. If B1 and B2 are proportional, the lines are parallel. The lectures will continue for another, let's say 45 minutes, and within next 45 minutes will be done with the entire revision of your entire mathematics. Now with this part we have already discussed the condition for parallelism. This is again one of the most crucial formula which IIT loves asking. Let's say two skew lines are there. Let's say two skew lines are there where R is given by this A1 lambda B1, R is given by second line is A2 plus mu B2. So I hope you remember A2 minus A1 cross B1 dot B2, dot B1 cross B2 upon B1 cross B2. Where is the formula? This is the formula. This is the formula for distance between parallel lines. So this is what you are given. It should be B1 here. It should be B1 here. Let me make that correction. It should be B1 here. So if two lines are there, of course, two lines are there, then the shortest distance between skew lines, no tukka, no tricks, simple, straightforward. box of b1, b2, a2 minus a1, or you can simply remember it like this: a2 minus a1 dot b1 cross b2 divided by magnitude of b1 cross b2. So it's like taking projection of a2 minus a1 on b1 cross b2, and that will give you the shortest distance. Do you all remember that? Similarly, this is also what we have been discussing. No confusion on that. Let me take a 5 minutes break and then we'll resume. So it is 12:50 right now. We'll resume at 12. We'll resume at 12:55. Is that okay? So let me take a break and we'll resume at 12:55. So it's a break of 5 minutes. So let me write it here. I hope it's visible. Break of 5 minutes. We'll resume at 12:55. I hope it's okay, everybody. Let me have some water and then we'll resume it. पानी तो है शायद पानी नहीं है पानी तो पानी I hope I'm clearly audible and visible, and we can resume with our discussion. So far we had a good discussion. I think this is what we have discussed. Now let's talk about the shortest distance. We already had a discussion on this. I'll not be covering the theory. I'll keep it to you. Now let's talk about algebra. I hope I'm clearly audible and visible. You all can hear me and see me properly. So there we go ahead with this discussion on algebra. Great, 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 great. Okay, now let's talk about this part. When you talk about algebra, I am now discussing complex numbers. Yes, some people were requesting that, sir, complex numbers. Here we are with complex numbers. First of all, iota, under root over -1. So if you are adding four consecutive parts of iota, that means iota to the power 11, iota to the power 12, iota to the power 13, iota to the power 14. It always results into 0. Remember that as a fact. The second conclusion is that iota to the power 4n plus 1, 4n plus 2, 4n plus 3, you already know, is 1 minus 1, sorry, 1 iota minus 1 is 1. Sorry, iota to the power 4n is 1, iota to the power 4n plus 1 is iota, iota to the power 4n plus 2 is -1, and iota to the power 4n plus 3 is of course minus iota. Right? These are the two conclusions I'll emphasize that you learn, because if you keep them at your fingertips, you'll be using them directly. So how can we derive them? You can derive them with the rationalization process. Now, no worries with that. No worries with that. Let's focus on the discussion now. Algebra is what we have done with. Sorry, vectors in 3D we have already done with. Multiplication, division, you already know of complex numbers. I'm not going to explain that. But yes, with conjugates, I hope you all remember this property that conjugate of a conjugate of a number, conjugate of a conjugate of a complex number is the original number. If conjugate of a complex number is added, you get double of real part. If conjugate of a complex number is subtracted, you get double of its imaginary part. And if somebody claims that, sir, a complex number is equal to its conjugate, then that will be true if it is purely real. So its opposite is done, which means in questions you will be told z is a complex number which is purely real. So what will I do? I'll put its conjugate equal to its complex number and I'll derive a result. Similarly, if I am told in a question that there is a complex number which is purely imaginary, so what will I do? I'll put this complex number equal to its negative conjugate. Everybody got that? Conjugate is distributable over addition, multiplication, subtraction, and division. Remember that. It is such a beautiful property. With this, we know that these are also some properties. First of all, you take the conjugate or raise it to a certain power, or you raise it to a certain power and then you take its conjugate. Both are same. Everybody knows that. From there, the next conclusion, if I talk about, these are what you already know. If two complex numbers are equal, then first of all, their magnitudes will be equal. Second, their arguments will be equal. Complex numbers are technically like vectors only. So if two vectors are equal, their magnitudes and their directions are same. Everybody got that? Second thing, if I am told that argument of a complex number is plus pi by 2 or minus pi by 2, you should not hesitate in saying that z will be a purely imaginary complex number. If I am told that argument of a complex number is 0 or pi, I'll say that that complex number is purely real. Everybody got that? Everybody understood that? These are also some additional properties. I'll begin with this one. ZZ bar is mod z square, very prominently, very widely, very repeatedly used by IDJE. Please remember it as a fact. Next one, of course, magnitude, modulus of complex numbers, is not distributable over addition or subtraction. That is getting converted into triangle inequality, where you find the maximum or minimum value of complex numbers. But if you ask me to distribute it over addition, product or division, then you can. So magnitude of two complex numbers, product or division, is equal to their individual magnitudes, product or division respectively. Is my language understood by everyone? From there, when I go ahead with this, this is the triangle inequality. What am I now saying here? Just look at this, it will give you a complete clarity. The sum or difference of two complex numbers magnitude. I repeat, the magnitude of sum or difference of two complex numbers will always be less than the sum of their individual magnitudes, and it will always be greater than the difference of their individual magnitudes. This is triangle inequality, which is used very widely in finding the maximum and minimum value of expressions which involve complex numbers. So please remember that. Yes, it is important for JEE Advanced. That's exactly why we are discussing this section. So I think we had a clarity on this. If you could remember, try to remember this as a result. It is self-explanatory. If I multiply it by z bar in the numerator and denominator, in that case, watch this AK Gamer. I'll try to help you out with this. We have recorded our sessions one shots as well. So you can revise it through that as well on this channel only on complex numbers. So that will help you a lot there. With this, let's talk about this. Argument technically behaves like logarithm. All I'm trying to say is that log of mn is log of m plus log of n. I hope you're seeing it. Argument is behaving like log only. I hope you remember log of m upon n is log m upon log m minus log n. I hope you remember log of m to the power n is n log m. So you can remember it like that only. It is exactly that like only. That inequality, okay, I'll bring into picture right now, possibly not, but yes, maybe in another some session, I'll take a question on it. Cauchy-Schwarz inequality, yes, I definitely will. Don't worry about that. And yes, remember that argument of conjugate of a complex number is equal to negative of it. It's like power minus 1, so minus 1 comes into front. Now, there is something really simple. I hope you'll remember it. Somebody says or tells you that their sum's magnitude is equal to their individual magnitudes. That will happen only when they are facing the same directions. If that sum is equal to the difference of their individual magnitudes, that will happen only when they are moving in opposite directions. That means they are 180-degree away from each other. So that's that. I hope you are writing it. Euler was a mathematician. He came up with this conclusion that your complex number, which is given as r times whole of cos theta plus iota sin theta, which is the polar form of a complex number, can be taken as r times e to the power iota theta as well, because he came up with this conclusion that cos theta plus iota sin theta is equal to e to the power iota theta. Something really amazing and phenomenal he came up with. What did he say? Irrational number raised to an imaginary power is equal to cos theta plus iota sin theta. Can you believe that? Something very beautiful he came up with. A very, very, very insightful and amazing expression, which will help you in dealing with a lot of problems based on complex numbers. I hope you understand this. I need not prove it right now. You just take it here, derive it with the help of trigonometric identities. You can do that. But right now I'm asking you to remember it as a result. This is something which is again very widely used. E to the power iota theta minus 1 upon e to the power iota theta plus 1. If you could remember this result directly, which is iota tan theta by 2, you will be getting a lot of conclusions. How are we getting this? By clubbing this and this. How are we getting them? With the help of sine 2 theta and cos 2 theta identities. You do it by yourself, you'll get the result. The next one is, of course, we know that a complex number z in Euler's form is given by r e to the power iota theta. R is its magnitude, theta is its argument. So its conjugate is given by r e to the power minus iota theta. There is theta as well, right? With this is the short technique. This is the short technique to find the square root of any complex number. So what is it? We are not getting it. All I'm saying is, let's say there is a complex number z, which is given as 3 plus 4 iota, and then you are asked to find its under root or square root. So let's say I'm asked to find out under root over 3 plus 4 iota. So one of the best methods to practice here is this formula, which says mod of z plus real z by 2 inside an under root, mod of z minus real z by 2 inside an under root. This will be its imaginary part, this will be its real part. What did I just say? All I'm saying is, what is mod of z? So first of all, tell me what is mod of z. Mod of z is, of course, 5 here. So it says mod of z plus real part divided by 2 and mod of z minus real part of z divided by 2. Now check for this sign. Iota had this sign positive here. So put a plus iota. If there was this negative sign here, put a minus iota and just put plus minus before it, because whether the positive of it is squared or negative of it is squared, you'll get the same 3 plus 4 iota. That's the beauty of it. I hope you're understanding. 8 by 2, that is 4. So this is 4 plus 5 minus 3. I'm really sorry. 8 by 2 is 4. Square root of 4 is 2. And there, 5 minus 3 is 2. 2 by 2 is 1. So this is 1. So 2 plus iota. So if you square 2 plus iota, you will get 3 plus 4 iota. Did you understand this short technique of finding the square root of a complex number? Will you remember it now? This is De Moivre's theorem. Do you all remember that? The conclusion is really simple. Let's say here, if I am asked to find out cos theta plus iota sin theta to the power n. So de Moivre suggested, which can be proved with the Euler's part as well. It can be written as cos n theta plus iota sin n theta. But when nth roots of unity comes into picture, which means if n is a rational number instead of integer, then this is one of the values of the values, nth roots. I hope you're understanding it. So with that, I hope now cube roots of unity come into picture, omega 1 and omega square. I hope you remember them. So with that, we know these results. Something very beautiful and interesting here is something very phenomenal. They are conjugate of each other. They are reciprocal of each other, which means 1 upon omega is omega square, 1 upon omega square is omega. Omega bar is omega square bar is omega. And they are the square roots of each other. Square root of omega is omega square. And square root of omega square is omega. Can you believe that? That's the beauty of complex numbers. And there you know that their magnitudes will be 1 because they are the cube roots of unity. Now something very, very, very important you need to understand is some of them, 1 omega and omega square is 0, omega cube is 1, but the same property is extended with any nth roots of unity. I'll talk about that, but first of all, when we plot these cube roots of unity, I hope you do remember, this is not the correct version of it. I'll do it here. So I hope you are understanding. Cube roots of unity, one is here, that's your omega, and that's your omega square. So it forms an equilateral triangle, and there this angle, and this angle is 120 degree. I hope no confusion on that. Similarly, you can plot nth roots of unity, and when you plot them, it is always an n-sided polygon, and that's how you plot these numbers. I have created a short on it. You watch this uploaded on our PWJ English channel. A short is uploaded there on it. Now, these are some identities. Forget them right now. Yes, this is something important. Cos theta, cos 2 theta, cos 3 theta. The angles are in AP. This is something which will be very useful not only in sequence and series, but in trigo as well when you're talking about a lot of formulae. What does it say? It says that this can directly be written as sin n theta by 2 by sin theta by 2 cos n plus 1 theta by 2. Actually, it is the formula for cos alpha plus beta, cos alpha plus 2 beta. There is a formula for that which we study in trigo. It is a corollary of that as well, that only. So if let's say sin theta, sin 2 theta, sin 3 theta is given, then also this part and this part remain same. The only thing changes is instead of cos, there is sin here. Please remember it. Please remember it. A lot of questions you will do directly based on trigonometric equations as well. If you do remember these formulae, please keep them with you. Sir, these are a lot many formulae. How are we going to keep them? I hope you remember the PDF of this entire session will be shared with you on our WhatsApp channel after the session. I hope you remember that. Good, good, good. Divya. With this is the rotation formula. Do you remember that? If there is a complex number Z2 minus Z1, there is another complex number Z3 minus Z1, and if it is rotated by alpha degree or alpha radians in the anti-clockwise direction, in that case, alpha radians in the anti-clockwise direction, then you write Z3 minus Z1 upon Z2 minus Z1 as modulus of Z3 minus Z1 upon Z2 minus Z1 e to the power iota alpha. Do you remember that? Coney method or rotation formula? I'm giving you a quick review of it. With this Coney method or rotation formula can be applied here as well. Z3 Z1, Z2 Z1. So Z3 minus Z1 upon Z2 minus Z1 is equal to mod of Z3 minus Z1 upon Z2 minus Z1 times e to the power iota theta. I hope no confusion on that. You do remember it, all the participants. If you want to find the distance, somebody was asking about geometry of complex numbers. This is that result only. If I want to find the distance between two complex numbers, then I'll say mod of Z1 minus Z2 will be the distance between AB. So if I want to prove or check whether they are collinear or not, I'll find the area formed by the triangle by these three vertices, or I'll say AB plus BC should be AC. What is AB? Mod of Z2 minus Z1. Mod of Z3 minus Z2. This sum should be equal to mod of Z3 minus Z1. If that is like that is happening over there, I'll say they are collinear. Similarly, let's say there is a circle. Let's say there is a circle. Let's say there is a circle. Let's say there is a circle with centered at Z0 having radius R. So with complex numbers, we write its equation as Z minus Z0 is equal to R. This is also very handy and very, very useful in your complex numbers journey. Now, if I talk more about it, I hope you know for complex numbers, centroid is Z1 plus Z2 plus Z3 by 3. We all know that. Just give me a second, students. We know one more thing, that this 9-point center, forget that right now. But if I talk about H, G and O, H is your orthocenter, G is your centroid, and O is your circumcenter. So this always divides, the centroid always divides this H and O into 2:1. They are always collinear except for equilateral triangle, because for equilateral they are coinciding, but for all the other triangles they are always collinear, and centroid divides this segment into 2:1. Please remember it as a fact. Everybody from here. This we already know. I think the only thing which you should now not forget is the difference of the roots under root d upon mod a. Everybody knows this. Just give me a quick thumbs up in the comment box if you all are aware of this fact. From here, when I talk about the next conclusion, you know how to convert a quadratic into a perfect square, and when you do so, you find its vertex. So if the coefficient of x square is positive, then it is upward facing parabola and its vertex is minus b by 2a comma minus d by 4a. So this is where you find its maxima or minima depending on the coefficient of x square. Great. So I'm making you revise all the formulae of 11th and 12th for your IIT JEE Advanced. Yes, this is that session only where all your formulae of mathematics will get revised. So all 11th and 12th will be there. And do remember that this PDF of all the formulae of mathematics will be available on our WhatsApp channel after the session. I hope no confusion on that. So with this, I hope you can continue with this discussion here. What am I given? The sum of the roots taken one at a time minus b upon a, sum of the roots taken two at a time c upon a, and so on, alternatively plus minus sign changes. And there we do remember this discussion. I hope you know that here, I hope I need not give you clarity on this part. Everybody knows that this part. Can I move ahead from here? With this is something very important. Let's say there is a cubic. So it will go from minus infinity to infinity. Of course, if the coefficient of x cube is positive. But if the coefficient of x cube is negative, if the x cube's coefficient is negative, it will go from plus infinity to minus infinity. So correct it, it's wrong. So if a is negative, it will go like this. I hope no confusion on that. Odd degree polynomial. But if the polynomial is even degree, if coefficient of x is positive, it will come from plus infinity and go back to infinity. But if the coefficient of x to the power 4 is negative, then it will come from minus infinity and go back to minus infinity only. Now it all depends on x-axis. How is it behaving? In that case, yes. No worries on that. Good to have you all. Great. Perfectly fine. With this, the next discussion. Yes, this is something you all should remember. Somebody was asking about Cauchy-Schwarz inequality. This is an extension of that only. I'm just keeping this slide in front of you. When you revise the notes, you go through it. These are some conclusions. I don't want you all to remember them now, because right now, learning them will be really difficult. But some properties related to AP, GP and HP you should remember. One property which is very widely used in AP, GP is that if terms are in AP, if terms are in GP, and if you take logarithm of all of these terms, then it will be an AP. Vice versa. If terms are in AP, and if you take anti-logarithm of those terms, then it will be forming a GP. Everybody got that? Now from there, if certain number, a fixed number is added to all the terms, it will still be an AP. If a number is multiplied, a fixed number is multiplied to all the terms, it will still be an AP. So these properties, I hope you remember that. If two APs, consecutive terms are added or subtracted, that also still remains an AP. Few direct, decent, straightforward properties. I hope this is self-evident, self-explanatory. I need not explain this part. This also is clearly self-explanatory. The only thing which I want you all to understand is this one. If A1, A2, A3 are in GP, then logarithm of them will be in GP. Please remember that questions are asked on that. This is also where students commit a lot of mistakes. Let's say 4 and 9, I'm finding the geometric mean. So 4 and 9, the geometric mean is 6. But let's say I want to find the geometric mean of minus 4 and minus 9. So a lot of people say it will be 6. I would say it's not 6. You don't do minus 4 into minus 9. 6 cannot be the geometric mean there. It should be minus 6. Everybody getting that? And of course, if you're finding the geometric mean of negative and positive, then the imaginary part comes into picture. Great, Mr. Kamble, good to have you here. And this is a simple observation here. Let's say there is an equation which has roots alpha and beta. So what we know is that arithmetic mean of these two numbers will be alpha plus beta by 2. Geometric mean of these two numbers will be root over alpha and beta. So with that, I'll say sum of the roots will be 2a and product of the roots will be g squared. So let's say I am in a question given the arithmetic mean and geometric mean of two numbers. So with the arithmetic mean and geometric mean of two numbers, I can write the quadratic, which will have those two numbers as its roots. Everybody got that? All the participants. Now from here, let's talk about few more conclusions. Shall I give you this formula? I hope you already know it. Sum of first and natural numbers. Sum of first and odd numbers is always n square. I hope you are pretty much clearly aware of it. Sum of squares of first and natural numbers, n plus 1, 2n plus 1 by 6. Sum of cubes of first and natural numbers, square of n plus 1 by 2. I hope you are pretty clearly aware of it. Now this is a short technique which I would have discussed, but method of difference I'll ask you to remember directly. But this VN method, this telescoping sum I'll give you. Let's say there is a question. Let's say there is a question. The question asks you sum of this. So there's a short trick. This is called telescoping sum, VN method only. Now VN method is simply here this, that 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So all of these terms are in AP. And one more observation you must be making, that its second factor here is 2 and it is beginning with 3. It is second factor is 5 here and it is beginning with 5, and so on till the last nth term, and this summation is needed to be found. It is amazingly easy and interesting. With telescoping sum or VN method, you can write the direct answer. What is the direct answer? First of all, take the difference between these two first and last factors. So 9 minus 1 is 8. Write that 1 by 8 outside. And then just do one thing. Which two things? Write this first term and last term with a difference sign between them. From the first term, remove the last factor. From the last term, remove the first factor. That's your answer. Isn't it interesting? Is it not simple? Is it not absolutely easy? Divya and Kamle, good to have you both, but put your complete focus and attention here. I hope everybody got this, or shall I re-explain this part, all the participants? Remember this as a short technique. It will save a lot of time of yours in the real examination hall if you encounter this kind of question based on VN method or telescoping sum. I hope you remember it. Log x greater than log y. All depends on a. If the base is greater than 1, the sign does not change. But if the base lies between 0 and 1, the sign changes. The same follows with these other conclusions as well. Regarding factorial notation, I hope you know this and this. The only thing which bothers me here is this part, that if somebody says x factorial is equals to y factorial, then don't be in a rush to conclude that x and y could be equal. The other possibility could be x or y could be 0 and 1 as well, because 0 factorial and 1 factorial is also 1. Will you remember that? Will you all remember that? Now, from here, this is something easy, understandable and doable. Let's say if somebody asks you the highest power of 300 factorial, 3 should be a prime here. That should be the case. So 100 by 3, then 33 by 3, then 11 by 3, then 3 by 3 should give you the highest power of 3. This is the principle of inclusion and exclusion. Let's say A union B union C. A union B union C will be A plus B plus C. Then A intersection B, B intersection C, C intersection A, minus minus minus. Then plus A intersection B intersection C. So plus minus alternatively goes, and that's how you derive or develop the formula for these cardinal numbers on sets union. I hope this formula I need not give you. NPR and NCR, you are comfortably aware of it. And the same formula comes here with this condition or conclusion. Let's say here, I hope this formula is you're already aware of. I need not give you clarity on this, where you say, let's say mathematics is a word. Mathematics is a word, and you are asked to write all the permutations of it. So of course, what you do is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are total 11 letters. You divide it by 11 factorial. Then you divide it by number of times a certain letter is appearing. So m is appearing twice. So 2 factorial and so on. So this is that formula only. I hope no confusion on that. Everybody getting that. So these are again some formulae which you all keep with yourself. I'll always say permutation is nothing but combination first. What does it mean? Let's say out of n objects, I wish to arrange r objects. So that can be done either with NPR Or I could do it when I select R objects and then I arrange R objects. So NCR into R factorial is NPR. Remember it. I think you're writing JEE Advanced. You must already be aware of them. These are few ones which you should keep at your fingertips. But something very crucial here is, I hope NCR is always NCN minus R. Second one is, if NCX is equals to NCY, then of course we can conclude X is equals to Y. But this is not only thing which could be true. Sir, either X is equals to Y or X plus Y could be N. So there are two possibilities or conclusions. Everybody knows that. Now there, what IDJ loves asking is this one. I personally remember it like this, that if this N are same and R are consecutives, so R and R minus 1. So N gets increased by 1 and you take the bigger R. So between R minus 1 and R, the bigger R is R. I hope you understood my language and you're getting it totally and absolutely and clearly. With this, when I move ahead, there are few more. I don't want you to remember them. I'll simply ask you to derive them as per the need of the question. Otherwise, you'll get confused. But this result you should keep with you because this is again used at a lot of places. NCR can be written as N by R, N minus 1 CR minus 1. Something very important you should keep in your mind when you're writing JEE Advanced is that in JEE Mains, it was a game of speed. But in JEE Advanced, it is of course a game of speed, but is more a game of depth, a good conceptual clarity. So how well you are dealing with the problems, what is your attitude, what is your mindset there, that also matters more here. And that game of stamina, that game of endurance, that paper 1, paper 2, a lot of permutation and combinations, a lot of different category of questions. There you are dealing with MCQs, integer type, MSQs, matrix match type. So different strategies are required. So it's like that total proper test match. Good temperament, good technique, and good talent. A combination of all three is needed. It is a true check of your abilities. Yes. Okay. Definitely. No, I'll be taking the first class, I think first or second, whatever it is. But in Laksh, I'll be taking the first class in the morning. And I don't know about the Gokul sir then, whether he has planned an extra class or not. These are again some conclusions. I hope something very common here is very well understood by you all. But if I'm taking the odd ones or the even ones, then it is 2 to the power n minus 1. I hope no confusion on that conclusion. From here, this is something easy, absolutely doable. Let's say there are n objects in front of me and different things are there. So how many ways can I have at least one? It is always 2 to the power n minus 1. Simple, straightforward, absolutely understandable. And there, this is also absolutely understandable. I'll take an example to make you understand all of this. Let's say in front of me, let's say there are 5 objects. Let's say object 1, object 2, object 3, and object 5. So I don't have this constraint that how many objects do I choose. I can choose 1 or 2 or any 3 or any 4 or any 5 of them. So in how many ways can I have at least one? So I'll say the total number of ways of choosing them is 2 to the power 5. Object 1 has 2 choices, object 2 has 2 choices, object 3, object 4, object 5. But out of which there is one case when I'm not taking any of them. So if I exclude that, this is the number of ways when I'm having at least one of them. It's same as total number of sets where at least one element should be there. Whosoever is asking for the PDF will be uploaded very soon on our WhatsApp channel. Once the session gets over, you'll find it on our WhatsApp channel. Sir, how do we find your WhatsApp channel? Our WhatsApp channel link is given in the description, so you can have it there. Now, when I go ahead with this, let's talk about the next part here. This is also a very interesting fact. What does it say? Let's say the objects are identical. So let's say there are let's say 10 apples in front of you, and of course let's say all the apples are identical. Now in how many ways can I choose apples? So I'll say the number of ways of choosing the apples when there is no constraint. So I can choose either 0 apples or 1 apple or 2 apples or 3 apples or 4 apples or all 10 apples. But since all of them are identical, I cannot make any distinction there. So that's where I say that the total number of ways will be 10 plus 1, that is 11. Why did I show 11? Why am I adding 1 here? Because number of ways of choosing 0 apples is 1. Number of choosing 1 apple out of 10 apples is 1. Whichever apple you choose will be counted as the same way because all the apples are identical. So that's why I'll say 11. So this is how you are getting or deriving these formula. This is also something very interesting. Let's say there is a number n which is raised or written as 2 to the power 2 into 3 to the power 5 into 5 to the power, let's say 1. And if somebody asks you the total number of prime factors of it. So what you will say, sir, prime factors will be 2, 3 and 5. So there are total 3 prime factors. But if somebody asks you the total number of divisors of it, the total number of factors of it, in that case, what do you say? So 2 can be taken in 3 ways, either as 2 to the power 0 or 2 to the power 1 or 2 to the power 2. So the number of ways 2 can be taken are 3, and the number of ways 3 can be taken are 6. 3 to the power 0, 3 to the power 1, 3 to the power 2, 3 to the power 4, 3 to the power 5. So the number of ways 5 can be taken is 2, either as 5 to the power 0 or 5 to the power 1. So 3 into 6 is 18, 18 into 2 is 36. So there are total 36 factors of n. Did you all get this? If somebody asks you to figure out the even number of factors, so for even number of factors, 2 must necessarily be included, which means what? 2 to the power 0 should be excluded. So 2 can be taken in 2 ways. So 2 into 6 into 2 will be the even number of factors. From total number of factors, if I subtract even number of factors, I'll get the odd number of factors. Or I can say it like this, that I need not include 2. So 2 should not be included one way. Into 6 into 2. So 1 into 6 into 2, that is 12. So there will be 12 odd factors. I hope I'm not teaching too fast. You are able to understand, digest and interpret all what is being said. I'm just being fast because I think that you're writing JEE Advanced. You're aware of these basics. You just need to get a go through of it. So I'm just giving you the glimpse of all what you already know. But if you find that I'm teaching a little faster, you can ask me, I'll slow it down. But I hope these all are what we have already discussed. This is D arrangement. I hope you know this formula. What does this formula say? Let's say I have 5 friends and I'm writing 5 letters to them. And if I ask you that in how many ways can I send these 5 letters to my 5 friends, such that, okay, Rakshita Malpani ji, with this 5 friends are supposed to receive 5 letters, but the condition here is that no friend should receive his destined letter, which means the correct letter should not reach to the correct friend. All incorrect letters should be received by them. So no correct letter should reach to the correct friend. I hope you're understanding the language. So that is given by D arrangement. So 5 friends, it will be 5 factorial times 1 minus 1 by factorial plus 2 by 1 by 2 factorial and so on until this final result, which is 1 by 5 factorial. And for certain values, I'll ask you to learn these values. Let me check whether they are, where are they? Let me find these values. I'll come back to these slides, don't worry. But let me find that D arrangement formula I have kept somewhere here for you all. I think it is missing. I'll get it done, but don't worry. I'll ask you to remember few values. Few values means at least one fact, D arrangement of 1 objects, D arrangement of 2 objects, D arrangement of 3 objects, D arrangement of 4 objects, and D arrangement of 5 objects. At least these 5 values you should keep with you at your fingertips. Now, the second one, the second method or the second approach or the second idea here. Let's say there are 13 people in your class. There are 13 students in your class, and I'm forming, let's say, 3 groups. So first group has size 5, second group has size 3, and the third group is of course 5 plus 3 is 8. 13 minus 8 is clearly how much? Again 6, again 5, right? So I should not keep it like this. Or can we do 4, 5? That is 9. 9 plus 4 is also 13. I'm taking a distinct size. So 6, 4 and 3. I hope it's fine. So now, please pay attention to this part. There is a group of 13 people, students. I want to form a group of 6, 4 and 3. So the short trick says here, you write 13 factorial divided by 6 factorial, 4 factorial and 3 factorial. This is the division. This is the division. I hope you're understanding it. Now I want to distribute it. I want to label those groups as A, B and C. So if labeling has also come into picture, you are now distributing it. So these 3 groups are supposed to be distributed among A, B and C. Then that 3 factorial should also be introduced. Everybody got this? I hope there is no confusion on that. Now with this, the next part, if let's say equal size has also turned up, which means what? Let's say again there are 13 students. Let's say there are again 13 students, but now the thing here is, let's say one group size is 3, another group size is also 3, 3 plus 3 is 6, 6 plus 7 is 13. So now I need to divide it into 3 groups of sizes 3, 3, 7. Again, the short trick remains same. What does it say? It says 13 factorial divided by 3 factorial into 3 factorial into 7 factorial. But with this division, what you do is, this needs to be divided by 2 factorial. Whatever size is getting repeated number of times, that factorial should be introduced here. So this should be divided by 2 factorial. I hope you're getting it, everybody. So with this 2 factorial coming into picture, that comes here as the 2 factorial here. This is the division. Let's say I want to distribute it. So I want to distribute it into three groups. So again, I'll introduce a 3 factorial here. I hope these basics of division and distribution you are aware of already, and that's how you do it. Now, the next thing, let's say there are n identical things. There are n identical things. They are to be distributed into R groups. So I hope you remember, to distribute n identical things into R groups, the formula is n plus R minus 1, C R minus 1. Do you remember that? Do you all remember that? I think this one I need to check, because where is it getting derived from? I don't know. But n plus R minus 1 C R minus 1 is absolutely correct. I hope you remember that. Let's say there are 10 chocolates and you want to distribute them among 4 kids. So 10 chocolates are identical. So how do you distribute them? 10 plus R, 10 plus 4 minus 1. So 10 plus 4 minus 1, C R minus 1. So that's how you distribute these 10 identical chocolates among 4 kids. With this, these are geometry based problems. I'll say simply read this theory. That is self-explanatory. You can go ahead with this. Binomial expansion, you all are already aware of. I think I need not tell you. Simply remember this general term. R plus 1th term is always given by NCR, x to the power n minus r and a to the power r. I hope you do remember the expansion of x plus a to the power n, the general term here. And of course, for 1 plus x also, you know that. I need not explain that. P plus 1th term, we already know. If somebody asks you the number of rational terms, you simply use your logic. You write its rth term and then you talk about the powers. The powers will give you the idea about rational and irrational terms. There, this is the short trick where I want you all to put your complete focus upon. Why am I saying this? Because this short trick will definitely help you a lot in generating something very beautiful and interesting here. What do I mean by this? First of all, let's say I am given x plus a to the power n, which is written as, of course, a when taken common can be written as a to the power n 1 plus x by a to the power n, where x is taking a certain value and I'm asking their greatest term. In JEE Advanced 2025 only, a direct question based on this property was asked, which we have already discussed in our marathon we conducted few days back. And such marathons will keep bringing in this week as well. I hope you're aware of it. And if you want the PDF of these notes, follow our WhatsApp channel. We'll be providing these notes there are absolutely free of cost. So first of all, I'll calculate m. What is m? We'll talk about that. But m is going to be mod x by a times n plus 1 upon mod x by a plus 1. Although you can simplify it by dividing it by mod x by a from numerator and denominator. So numerator becomes n plus 1 and denominator becomes 1 plus mod a by x. That is also nothing but your m. Once you have calculated m, there are two choices, two possibilities. M could be either an integer or m could not be an integer. If m is an integer, your tm and tm plus 1 are going to be the greatest term numerically. And here, if m is not an integer, in that case, term, which is GIF of m plus 1, will be the largest term here. Remember it. Questions are asked on it from binomial. Please do that. Now with this, the next thing is here, pretty sure you all are aware of it. I'm skipping this part. This is what we have already discussed. Multinomial theorem it is. So here, remember it. If n is a positive integer and x1, x2, x3 until xk is raised to the power n, and you are asked to write its expansion, of course, it is given by, this should be written somewhere here. So x1 to the power alpha, x2 to the power, what is it, alpha 2. Is it alpha 1? Yes, alpha 1, then alpha 2, and so on until xk to the power alpha k. Alpha k. So let me remove it from here so that it is not confusing to you when you revise it from the notes. Give me a moment, students. So getting back to the discussion we all were having, please pay attention to this part. I repeat, this is how you write the expansion of a multinomial theorem. Everybody got that? All the participants. And there you need to remember that alpha 1 plus alpha 2 plus alpha 3 till alpha k, this sum is always equal to n. This is the expansion of multinomial theorem. Please remember that result. It will be very handy and useful. This is what we have already discussed, but still I'll say, remember it. Let's say this is an expansion, x1, x2, x3 until xk raised to the power n. And somebody asks you, how many distinct, dissimilar terms will be there in this multinomial expansion? The answer is really simple. The number of ways of distributing n identical objects among k people, that is n plus k minus 1, ck minus 1. Please remember it. Please, please, please remember this as a result. It will be again very handy and useful for you all. From here, the next result is Sarus rule. Sarus rule was developed by mathematician Sarus. He gave you a short technique, or you may call a trick, to find out the expansion of a determinant in a more quicker and less complicated way. Let's say if there is a determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. These are the three columns of it. So Sarus said, repeat the first two rows A1, B1, C1, A2, B2, C2, and then start taking product along the principal diagonal. So A1, B2, C3, A2, B3, C1, and A3, B1, C2. That product sum you find as P, let's say, for a while. Similarly, take the product along the non-principal diagonal elements. So this, and this product you take, and then you take this sum, let's call it n. So when you subtract n from P, you get the value of the determinant. Will you all remember that? All the participants. Are we clear on that? From here, I hope you remember it. If you are multiplying any row or any column with its corresponding cofactors, you get the value of the determinant. But if you multiply it with any other rows or columns cofactors, the value you get will be 0. Third conclusion, the determinant of the cofactors elements will be equal to the original determinant raised to the power n minus 1. Yes, please remember that. Good odd one. I'll again ask you, let's say there is a determinant and I form another determinant with the help of cofactors of the original determinant. Then this determinant, which is formed by taking the cofactors of the elements, will be equal to the original determinant raised to the power n minus 1. Please, please, please remember that. Please do that. Now with this, I'm moving towards the next part. Yes, I hope you remember it. Concurrent, if three lines a1x plus b1y plus c1, a2x plus b2y plus c2, a3x plus b3y plus c3, if these three lines are concurrent, if they are passing through one single point, then this is 0. If this second degree equation in two variables, which could be either pair of straight lines or a conic, where it could be circle, parabola, ellipse, or hyperbola, it could be representing a pair of straight lines if this determinant is 0. So what is this determinant? ABC, HGF, HGF. What are ABC and HGF? I did not tell you. A, B, and C are your coefficient of x square, y square, and constant term. HGF are your half of coefficients of x, y, x, y, x, and y. With this, something very crucial on which every year in mains and advanced questions are asked. Now, what does it say? It says that if you are dealing with equations, let's say in three variables, we find first of all delta. What is delta? The determinant of the coefficients x, y, z. So that delta is not 0 if then we say that it will have a unique solution. And we say the system of equations is consistent. But if delta is 0, now there are two possibilities. If delta is 0, but at least one of delta x, delta y, delta z, or you call them delta 1, delta 2, delta 3. I hope you know how to find delta x, delta y, and delta z. If at least one of them is non-zero, then we say it will have no solutions and it is inconsistent. But if along with delta 1, delta 2, delta 3, all are 0, then we say the system of equations is still consistent, but this time it will have infinite solutions. I hope you know that. If the constant terms are 0, that means the system of equations is homogeneous. I hope you understand the meaning of the term homogeneous. In that case, it will have either trivial solution or non-trivial. Trivial means what? X, Y, Z all are 0. But non-trivial means at least one of X, Y, Z is non-zero. In that case, we say it can happen only when delta is 0. What do I mean by that? If it has a non-trivial solution, that can happen only when delta is 0. We will use this property or idea here. These are some direct expansions which we use. We don't derive, we don't develop them in the real examination hall. For example, here, if you are seeing 1a square, 1b square, 1c square, so don't start deriving it again in the examination hall. You don't have that much time. Directly substitute it by a minus b, b minus c, c minus a. The way others are also written in front of you. I'll ask you to remember these two as well. 1, 1, 1, abc, a cube, b cube, c cube is having this as its expansion. And the most crucial one, ABC, BCA, CAB. ABC, BCA, CAB should be taken as a cube plus b cube plus c cube minus 3abc. Please remember that. Please, please, please do remember that. From here, I hope you remember, if there is a matrix, then any matrix, the way we could write a function as a sum of two functions, even and odd, Similarly, a matrix can be written as a sum of two matrices where one of them is a symmetric matrix and the other one is a skew symmetric. Symmetric and skew symmetric, I hope you are aware of. If A transpose is equals to A, that is symmetric. If A transpose is equal to minus of A, it is skew symmetric. Everybody knows that. Now here are some properties. I won't ask you to remember them. You develop it by yourself. In the real examination hall, you cannot remember this. You just derive. Let's say you want me to explain one of the, then I'll say, let's say I want to check whether AB minus BA is skew symmetric or symmetric. So what am I told? A and B are skew symmetric. So A and B are skew symmetric means what? A transpose is minus B minus A and B transpose is minus B. So I want to check whether it is symmetric or skew symmetric. All I'll do is, let's say this is X. Let's say this is X. So let me find X transpose. So X transpose will be AB minus BA transpose. So transpose has this beautiful property that it is distributable over addition or subtraction. So that means what? I can distribute it like this. I'll write it as AB transpose minus BA transpose. But I hope you to remember, transpose and inverse reverse the order when you do it on product. So AB transpose will be B transpose A transpose. BA transpose will be A transpose B transpose. With this, when I move ahead, B transpose is clearly minus B, A transpose is minus A. So this is minus B minus A, that is BA. A transpose B transpose is minus A minus B, that is again AB. So BA minus AB is what I have received. I have received BA minus AB, which means if I take negative common, it will be AB minus BA, that is minus of X. What is minus of X? X transpose. So if X transpose is minus of X, that means X was a skew symmetric. So there are a lot of results. I'm absolutely not asking you to remember or memorize them, but I'm giving you the process or the method to figure out whether they can be symmetric or skew symmetric based on this idea. Everybody got that? Now from here, the next few results. I hope you know that whether you take the determinant of a matrix or its transpose, it will be same. Determinant over product can be splitted. We know that if there is a matrix which is orthogonal, then its determinant will be +1 or -1. If there is a skew symmetric matrix of order odd, then we know its determinant will be 0. Straightforward properties, I hope you know that. And if there is a skew symmetric matrix of even order, then remember it will be a perfect square. Now, something on which IIT JEE madly asks questions are these ones. Determinant of Ka is k to the power n times determinant of A. Determinant of A to the power n or matrix A to the power n's determinant will be same. If A is a diagonal matrix, then its determinant will be product of all the diagonal elements. I hope you do remember that. These are some properties which I'll say the most important slide of our entire discussion, because on which I'll be showing you a lot of properties on which IIT JEE asks a lot of questions. First one, A times adjoint of A or adjoint of A times A. There should be A here, so there is a typing error. It should be adjoint of A times A. Both are equal to A times determinant of A, and let me check whether there is a correction or not, because I think, let me come back to this. I hope you remember, what do we know? That A inverse is what? Adjoint of A upon determinant of A. I hope you remember that. So there is a small correction here. If I multiply it by A on both these sides, so it will be A inverse, which is equal to what? A times adjoint of A divided by determinant of A. So if I push that determinant of A here, this is what I get. So this should be A times adjoint of A, I hope you remember it, or adjoint of A into A, that's determinant of A into I, which means there is a small correction here. This A should not be here. Everybody got this, all the participants. Now the next one. This is one of the most important properties. Remember it. Determinant of adjoint of adjoint of adjoint. Let's say this adjoint is appearing m times. This adjoint is appearing m times. This adjoint is appearing m times. So this is given by determinant of A to the power n minus 1 whole raised to the power m. Will you remember that? This has its corollary. Adjoint of A is determinant of A to the power n minus 2 times A. And if I take its determinant, it will be determinant of A to the power n minus 1 raised to the power 2. Similarly, adjoint of Ka is k to the power n minus 1 adjoint of A. We know this property. I am asking you that go through this slide one more time, and please don't forget this. This is something very important. All the students who are watching it sincerely, I hope I'm not teaching too fast. You're able to digest and comprehend whatever is being said. No confusion on whatever is done so far. The next part, probability, we know odds against odds favor. Let's say I'm told odds in favor. Odds in favor for an event are 2:3. That means 2 are the favorable ways, 3 are the non-favorable ways. So the probability of it, the probability of happening of it will be 2 are the favorable ways divided by total number of ways, that is 2 plus 3. So I hope you understand odds in favor, odds against. That is something very much understood by you all. That's Bayes theorem. I hope you know that, you know how to apply it. That's your binomial distribution, probability distribution here. There three things are there. When you are given n and p, n and p, so np will give you the mean, the variance is given by npq, and of course square root over variance is your standard deviation, or square of standard deviation is variance, so standard deviation is root npq. Please remember these formulae. JEE will surely ask a question on it where these formulae will be used. Please remember this. I hope you will. Then of course 1 1 1 1 onto many one mapping, we know for 1 1 mapping is mpn ways, for 1 1 onto it is n factorial ways, for many one it is mpn, that is 1 n total minus this, I mean total minus this will be this. I mean if it is not 1 1 it is many one, so 1 minus this will be this. I hope you got my point very clearly here. Great. How a game of card is played, that's what you know. This is your de-arrangement formula which I was talking about, as we have already discussed it. These are all those 5 values which I was wanting to show you. For n is equals to 1, de-arrangement is 1. For n is equals to 2, I think there is some typing error here, d2 d3, I think they have mistakenly written something else, so let me correct it. I'll get it corrected once it gets uploaded, don't worry about it. Before uploading it, I'll make this correction. Now we'll talk about the part trigo. I hope I'll simply start showing you the formulae. We'll give you this list of formulae which you can revise by yourself. I need not tell you about this quadrant theory. You already know that. You know the formula of sine, cos, tan, cosec. You know when do they become 0, when do they become 1. So these general results you all are aware of, because if you don't know, then you will be committing a lot of problems. This is something which I want to put your complete focus upon. Sin a plus b, sin a minus b, sin square a minus sin square b, or cos square b minus cos square. But for cos a plus b, cos a minus b, it is cos square a minus sin square b, or cos square b minus sin square a. Please remember that. Similarly here, these are also which you are already aware of. These are also which you are already aware of. Something which is very crucial here is sin 3a, this version. Similarly for cos 3a, this version, please don't forget that. These are also which you have already studied. I need not explain them. These are some standard angle formulae which I would ask you to memorize. Few of them are these. Let's say 15 degree you should keep with you, sine and cos at least. 18 degree also you keep with this you. This is very widely used in questions a lot many times. And 36 degree also you should keep. 22.5 is of course half of 45, so that also you should keep. So a few of these you could keep with you. It will be very handy and very useful. You won't have to waste your time in deriving few values. I hope you got this. And that is something very crucial. You all are already aware of. A sin theta plus b cos theta always lies between this and this. I need not prove that. Everybody knows that. From here, of course, these are the general results. The trigonometric equation based questions are asked. Then you are asked to write the general solution. So general solution, let's say if sin theta is equals to sin alpha, we know it is n pi plus minus 1 to the power n alpha. If cos theta is cos alpha, then 2n pi plus minus alpha. Tan theta is tan alpha, then this. And when are they 0, when are they 1, and when are they minus 1? You know it from the graph, so you don't have to revise or memorize or learn them. And of course, these are the results which you know. But if sin square theta is equals to sin square alpha, or cos square theta is equals to cos square alpha, or tan square theta is equals to tan square alpha, the only general solution you need to remember is theta is n pi plus minus alpha. I hope I'm not teaching too fast. You're able to digest all of this. For inverse functions, the domain and range, I hope you are comfortable with this. The formula here, this is where students commit mistakes. Sin inverse of sin theta is theta, but theta should be between minus pi by 2 to pi by 2 only. Then only it is done. Otherwise, we'll bring it into the principal domain by using the cyclicity or periodicity of the functions, and there I'll get it done. Similarly, this is also a problem where students commit a lot of mistakes. Sine of sin inverse of 5, if I ask you, it will not be 5. It will not be defined technically. So this will be x only when x is from minus 1 to 1, and so on. I hope you're looking at this. These are also the properties which you have studied already in inverse trigonometric functions. Sine inverse is an odd function, minus comes out as it is. But for cos inverse minus x, we write it as pi minus cos inverse of x. I hope you remember all the other formulae also, which are followed as it is. Again, these are also some really crucial ones. Sine inverse x, I'm really sorry, it should be plus here. Sine inverse x plus cos inverse x is pi by 2. Similarly, others are also followed. This one is very widely, very prominently used, not only in this here, but telescoping sum VN method is when we use. There also you use this version of tan inverse A minus tan inverse B, which is written as tan inverse A minus B upon 1 plus AB. Do you remember that? That is something very handy which you could be using. Final section of our discussion, with which we'll be concluding this session, coordinate geometry. I hope I need not give you the distance formula, the section formula, internal division, external division. You already know this. This image is self-explanatory there. This is the part where you should pay your complete attention to. Let's say there is this straight line. A and B are joined. This is a line segment. So if this straight line divides it into ratio lambda is to 1, the short trick here is lambda is to 1 will be negative of power of this point with respect to this line divided by power of this point with respect to this line. Amazingly easy and terribly useful if you want to get your answer very quickly. Now, of course, stair method for finding the area of any polygon, not just a triangle, quadrilateral, pentagon, hexagon, regular, irregular, whatever it is. Half of mod of stair. I hope you know how to expand the stair. I hope you all very well know this minus this minus this, and so on. So better than determinants, it is very useful, but you just need to ensure you're following a certain order. Either you're taking vertices clockwise or anti-clockwise. Don't abruptly jump here to there. You won't get the correct answer in that case. The next result is, of course, this is a very interesting trick here. Let me share that trick here very clearly. Let's say this is a triangle here whose midpoints are given. So let's say this point is 2, 1, this point is 1, 3, let's say, and this point is, let's say, 0, 7. Now I want to find this, this, and this. So there are methods, but I'll say there is a short technique. What is that short technique? The short technique is add this and this, subtract this, you will get this, which means 0 plus 1, that is 1, 1 minus 2 is minus 1. 7 plus 3, that is 10, 10 minus 1 is 9. Did you get this? Easy and interesting it is. Similarly here, this plus this minus this will be this, which means 2 plus 1, 3 minus 0 is 3. 1 plus 3, 4 minus 7 is minus 3. Did you all get this? On the basis of this, in the comment box, quickly tell me what will be the coordinates of this. What will be the coordinates of this? How will I find it? For this, this plus this minus this will be this. Of course, these are the midpoints. I hope I need not explain this part. These are the midpoints. Then only it is applicable. I hope you're getting it. So here, 0 plus 2 is 2. Minus 1, that is 1. 7 plus 1, 8. 8 minus 3 is 5. I hope you got this, everybody. Great. Good to have you all. That's good, odd one. I'm glad that you are there, sincerely attending it from the beginning. And that's exactly what I was trying to tell you when we were talking about 3D. In 3D, the formula was terribly confusing. But in 2D, with this table, you can remember it. Technically, you don't need these formulae for incenter, orthocenter and all, but something you need the formula for centroid, you need the formula for at least orthocenter and circumcenter, and one formula for incenter. These are your X centers, for which I wouldn't recommend, but still if you can, you should. The formula is simply like this. For centroid, it is x1 plus x2 plus x3 by 1 plus 1 plus 1. So for centroid, m2, m1, m2, m3 is replaced by 1. For incenter, sine A x1, sine B x2 and so on. For orthocenter, it is tan A x1, tan B and so on. For circumcenter, it is sine 2x1, sine 2b x2 and so on. So this is how you derive this formula. So this table is amazingly handy for you all to go through this formula. Now, I hope you know angle between two lines. I hope slope of a line. I hope parametric form of a straight line. Let's say on this straight line, there is a point x1, y1 from which r distance away, there is a point xy. So that point xy can be written as x1 plus r cos theta, y1 plus r sin theta. Are you all aware of this parametric version of this straight line? Are you not? Give me a quick update on this. I think if I want to define the position of a point with respect to a line, I hope you know that power of those 2 points will be either positive or both negative if they are on the same side of the line. Or if power of those points, if it is of the opposite signs with respect to that line, that means they lie on the opposite side of a line. Do you all remember that? I hope no confusion on that. If I want to find out the distance of a point from a line, this is the formula, perpendicular distance of a point from the line. I hope I need not explain this, but if I want to find the feet of a point with respect to a line, I hope feet is given by, let me make some correction here, it should be x2. So let's say if coordinates of feet are x2, y2, then x2 minus x1 upon a, y2 minus y1 upon b is negative of ax1 plus by1 plus c upon, it is not under root. With distance formula, it is under root, but with image and feet, it is simply a square plus b square. There even I still today also commit mistake. A lot many times in rush or in speed or in flow, I take square root a lot many times and get the wrong answer. So in JEE Advanced also you may commit that error. So take care of that under root sign. Under root is there with the distance formula, not with the mirror image or with the feet. This is we already know. For circle, h comma k will be the center, r or a will be the radius. Parametrically, a point will be h plus a cos theta, k plus a sin theta if the center is h comma k and radius is a. Similarly, for general standard equation of a circle, this is how you write the equation of a circle, for which negative of coefficients of x and y, negative half of the coefficients of x and y are your coordinates of the center, which are minus g and minus f, and the radius is given by under root over g square plus f square minus c. It is minus c, it is not c square, it is minus c. Everybody got that? I hope I can move ahead from here. The next part is related to t is equal to 0, as we have just discussed. No, it is not t, I'm really sorry. This is how you define that diametrically, if x1 comma y1 and x2 comma y2 are the extremes of the diameter of a circle, this is how you write the equation of the circle, and this is how you find the maximum and minimum distance of a point from a circle. Let's say this is a circle, this is a point P. So I hope you remember its minimum and maximum distance. Its minimum and maximum distance will be given by this. This is how you connect it. So this distance will be the minimum distance and this distance will be the maximum distance. And whether this point lies inside the circle, outside the circle, or on the circle, the maximum and minimum distance formula remains same. You find that point's distance from the center of the circle, you add radius to it, it will be the maximum distance. And you find that point's distance from the center of circle and you take the difference from its radius, it will be the minimum distance of that point from the circle. Remember that? Do you all remember that? This is how you find the length of a tangent drawn from an external point to a circle. Sir, what does it mean? It means if there is a circle, there is an external point. So if I take the point's power with respect to the circle and if I take its square root, it will be the distance of that point from that circle. Technically, it means that distance is not there. The technical term should be the length of the tangent. So this is a point here from which I have drawn a tangent to this circle. So this circle's tangent which I have drawn on circle, this tangent which I have drawn from this external point, this length is root S1. You can request for it, Ajit. You can definitely request for it by putting a comment, not in this live chat, by putting a comment in this video. I'll definitely forward that request to the respective faculties. So under root S1 is your distance formula. Sorry, not the distance formula. The formula for the length of the tangent. Please remember that. What is S1? The power of this point x1 comma y1 with respect to the circle. The next is, of course, t is equal to 0. I hope you remember that. T is equal to 0, which means what? X square should be replaced by x1, y square by y1, x should be replaced by x plus x1 by 2, y should be replaced by y plus y1 by 2, and if there is hyperbola, there will be term in xy. So xy should be replaced by xy1 plus yx1 by 2. So that is how you write t is equal to 0. So if there is a point lying on this second degree equation in two variables, it could represent a circle, parabola, ellipse, hyperbola. In that case, a point lying on it will have the tangents equation given by t is equal to 0. Do you remember that? And yes, this is also gives you the equation of the chord which is bisected. So if there is a circle which has a chord and chord is bisected at x1 comma y1, it is given by t is equal to s1. I hope you know s1, power of that point with respect to that curve. T is of course this which we have just discussed. Moving ahead with this, if there are two circles, they could be disjoint, totally different, which means what? R1 plus R2 will be less than C1, C2. C1, C2 is distance between those two circles. In that case, number of common tangents will be 4. 2 are the direct common tangents and 2 are the transverse common tangent. If they're touching each other externally, that means what? R1 plus R2 is C1, C2. The distance between their centers is sum of their radii. In that case, 3 common tangents. 2 are direct common tangents. The third one is transverse tangent, and that can be given by the common tangent as well. This transverse tangent. The radical axis is also, it is called. So from circle 1's equation, if I'm subtracting circle's 2 equation, that will give me this radical axis equation. Everybody got this? Similarly, these are the other cases which are self-explanatory, self-evident. I need not explain, I think. For conic, remember this condition. For a parabola, eccentricity is 1. This is regarding to this ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. If this is the second degree equation in two variables, it could represent either a pair of straight lines or circle, parabola, ellipse, or hyperbola. So if its delta is 0, then it is pair of straight lines. But if delta is not 0, then it is conic. I hope you remember delta A, B, C, H, G, F, H, G, F. So here, if it is conic, that means if delta is not 0, there are 4 cases. Which are 4 cases? Either eccentricity is 1, or it is 0 to 1, or it is 1, or it is greater than 1. If it is 1, it is of course parabola. I think there is some correction here. If it is hyperbola, it should be greater than 1. So this should be greater than 1. So if eccentricity is 1, parabola. If it is between 0 to 1, ellipse. Or if it is greater than 1, it is hyperbola. For rectangular hyperbola, we know eccentricity is root 2 clearly, which is again greater than 1. But here, if h square is equals to AB, it will be a parabola. If h square is less than AB, it will be ellipse. But if h square is greater than AB, it will be hyperbola. For rectangular hyperbola, A plus B will be 0. Remember this table, it will be amazingly handy and useful for you. Now, when I talk about a parabola, I hope you know a few things. This is the standard parabola, y square is equals to 4x, for which focus is at a comma 0, vertex is at 0 comma 0. Your directress is x is equals to minus a. Your latus rectum is this line, which has its extremes at L and L dash. So length of latus rectum is 4a. I hope you know these basics. And this is how you take any point parametrically, 80 square comma 280. I hope you know that. Similarly, if I define these things, which is self-explanatory, I'll simply say that here, this is how you write the equation of tangent to it in slope form, where the condition for tangency is c is equals to a by m. I hope you remember that. I need not explain that. If you want better explanation, I can be more elaborative. And I think this is sufficient. This is what you must have been doing exactly. I'm just keeping it as a glimpse. This is the reflection property of a parabola. On this, questions could be asked in physics or in maths as well. If there is a ray coming from infinity parallel to the axis of the parabola, when it touches the surface of the parabola, it gets reflected and it passes through the focus of the parabola. I hope you do remember that. From here, moving ahead from here, this is an ellipse. We know x square upon a square plus y square upon b square is equals to 1. Eccentricity for an ellipse, I hope I did not discuss. Eccentricity for an ellipse, you already know. For it, the foci will be at a comma 0 minus a comma 0, a by e, and x is equals to minus a by e will be the directrices. Latus rectum is 2b square upon a for this standard ellipse. I hope no confusion on that. And we already discussed that for ellipse, eccentricity is less than 1. I hope no confusion on that. Everybody got this. Horizontal ellipse means what? There a is greater than b, but if it is vertical ellipse, a will be less than b. Everybody getting this, all the participants. And there, when I talk about hyperbola, it is your standard hyperbola, x square upon a square minus y square upon b square is equals to 1. For hyperbola, we know eccentricity is greater than 1. Again, it is same as ellipse, ae comma 0 minus ae comma 0 your foci, x is equals to a by e and minus a by e are your directrix. 2b square by a is your length of latus rectum. That is what you should know. This is regarding your rectangular hyperbola. This is your xy is equals to c square, for which, of course, yes, eccentricity is root 2. But few things you should know. The vertices will be at c comma c and minus c comma c. And these are the other results based on it, which I think you can skip. So we are done with this session, with this amazing session, with this phenomenal session of your complete revision of all the formulae of entire mathematics of IIT JEE. Sir, what if we want this entire notes? So complete formulae of mathematics if you want to avail for your JEE Advanced. Sir, how can we have this entire PDF? This entire PDF, this complete PDF can be availed by you by following our WhatsApp channel. Sir, how do we follow your WhatsApp channel? Trust me, the link is given in the description. You just check the description, you'll get the link. So great. A lot of students were sincerely attending it. That's brilliant. Good to have you all. Thank you so much. You must have gotten something decent out of this session. Shall we call it a day now? Thank you so much, everyone. You have been a great audience. Take good care of yourself. Good day, everyone. Good day.